course by Simplilearn. If you want to start your journey in AI, machine learning, or even data science, Python is one of the first skills you need to master. But don't worry, we are not going to make it complicated. In this course, we will break Python down into simple, beginner-friendly way so you can clearly understand how it works and how it becomes the foundation for AI. We'll begin by understanding why Python is so widely used in the world of AI. Then we'll set up the essential tools you'll need, including VS Code, Jupyter Notebook, Anaconda, and Google Colab. After that, we'll move step by step through the core Python concepts such as variables, data types, operators, input and output, lists, tuples, dictionaries, sets, conditional statements, loops, and functions. And the best part is that you don't just learn these topics as theory, you'll also understand how these Python basics connect to real AI machine learning workflows. So by the end of this course, Python will no longer feel confusing. You'll have a strong foundation to confidently move forward into AI, machine learning, and data science. Before we begin, if you're interested in mastering the future of technology, the professional certificate course in generative AI and machine learning is a perfect opportunity for you. Offered in collaboration with the ENICT Academy IIT Kanpur, this 11-month live and interactive program provides hands-on expertise in cutting-edge areas like generative AI, machine learning, and tools such as ChatGPT, DALL-E E2, and Hugging Face. You'll gain practical experience through 15+ projects, integrated labs, and live masterclasses delivered by esteemed IT faculty. Alongside earning a prestigious certificate from IIT Kanpur, you'll receive official Microsoft badges for Azure AI courses and career support through Simplilearn's Job Assistant program. Hurry up and enroll now. The link is given in the description box below and in the pinned comments. Now, before we begin, here's a quick question for you to answer. Which Python concepts helps us reuse code instead of writing the same logic again and again? Is it variable, function, comment, or operator? Drop your answers in the comment section below. Let's get started.
We are going to start with this, first course, which is going to study the basics of Python. Python will be our primary focus for the entire program. We will use Copilot, so there will be Copilot material later on in the program, but like in this first course, we're going to be focused on Python, and for most things, we will be using Python. Even when we use Copilot, it will produce Python code. Everything we do will be in Python. I think one of the things is by the end of the program, if anything else, you guys will be in a much better position with Python. You'll be better Python coders by the end of the program. If you don't learn anything else, you'll get better at Python, I promise. Because that's all of our examples, all of our demos, everything we do will be in Python. So you'll get better at it for sure. And we'll have a lot of practice to do that. Okay. So this first lesson is all about an introduction to what Python is. So if you're completely unfamiliar with it, totally fine. We will get you up to speed and talk about the fundamentals and how to set everything up on your own computer, and talk about the various ways to utilize Python. That some of it will involve a setup you can do on your own computer. Some of it will involve some cloud resources so that you don't need to set anything up on your computer if you don't want to. We'll have options there, which will be nice. So I will show us those and walk us through those. But this first lesson, all about the basics and getting set up. So what's interesting is, like, at the beginning of every lesson, we usually have this kind of engagement or discussion. But we've kind of already asked you guys about this of if you're familiar with programming, if you're familiar with Python. But one thing I want you to think about a little bit is that, especially as we go along and learn about what Python is why is Python the chosen language for AI? So why is it the one that everyone uses to do AI? And I think what you're going to learn is that it has a really amazing ecosystem that has been around for a long time that supports AI in particular. So Python is the go-to for anything AI, data science, machine learning, anything in that sort, because it's been used for so long for that, and it has such a community and ecosystem around it. That's something we're going to learn. It's also really easy to learn and use. which makes it nice to be kind of an introduction to the field. It doesn't take a lot to get started in it because it's so easy to work with. I can tell you as someone who's gone through that experience, like I studied mathematics in college and in graduate school and studied like probability and statistics, but I was able to teach myself Python primarily and use that to get into kind of data science and machine learning in the industry. So, and I think that's a common story is people, and I've seen that from many learners coming from different backgrounds. They've been able to pick up Python pretty easily because it's a very easy language to understand and the syntax of it. And there's so many tools within it that make it really easy to work with. So I promise it won't be as daunting as it may seem. Even if you're coming at it from zero experience, I think you'll find this is the perfect way to get into programming and get into data science and AI and machine learning because it's so easy to pick up and learn and it has such a nice, rich community ecosystem. So just wanted to mention that. Okay. So some of our objectives for this first lesson will be to talk about programming languages in general and programming in general. So maybe, more generic than Python, just, what do general programs look like? What are some of the building blocks of programs that are important? What are some of those key principles of programming that we will want to follow as well, even if we're doing Python for AI purposes? Um, so just talk about programming in general and then kind of zoom in on Python as we go along. One of the things we'll be interested in doing is just getting you guys set up. So talk about how we can configure Python for you to use on your own machine, but also have some options that don't require installing anything on your own machine, which is nice. And then, as I said, we'll kind of zoom in on Python, talk about its benefits, some of the nice features. I've kind of already mentioned it, really big community around it, easy to learn. We'll just talk about those more in detail, talk about why it's so popular in the AI world. And then we'll get into some very fundamental things specific to Python. So once we talk about the background, get you guys set up, we'll go into some of the syntax basics, things like identifiers, things like indentation, comments, some of the basics of the code that are going to be important for you to kind of get started with. And then talk about some of the basic data types that Python offers to manipulate and work with data, which of course is important when as we go forward and do anything with data, which of course with AI we will be interested in doing. But these are the objectives of just this first lesson. As we go forward, we're going to learn about many other basic topics within Python. So things like how to write functions, how to build objects, how to manipulate our flow of the program with like things like if else statements, things like loops. We'll learn all about that in kind of the next lessons after this one. But this is all the content for this lesson. I anticipate today we will get through all of this today and then get into the second lesson, which will get into those kind of if else and loops. So I'm sure by today we'll get into those. All right. Any questions on kind of what we're going to learn in this first lesson? So mainly trying to get you guys set up, give you some background on Python, and then towards the end of the lesson, get into some basics of the syntax. Kind of the goals, I would say. Okay, so when we talk about programming, what do we mean by programming in general? It's really synonymous with instruction. So programming really means giving or writing instructions for a computer to perform tasks. So these instructions we write down in what we call code, but those are just telling the computer what to do. And of course, the computer's not going to do anything unless we write down these instructions. So these instructions can do really powerful things. They can power, whole applications, things that we use every day, like Microsoft Word, PowerPoint, Excel, those kind of things. They can automate tasks. They can power websites. They can do AI, right? So we can have things like ChatGPT and Alexa and Siri, et cetera, et cetera. Um, these are all powered by instructions telling the computer what to do. One of the things that we will get better at as we go along is figuring out how to write these instructions in Python. Python is going to be the language we write those instructions in, and they will be executed by a Python program. But we should think of programming in general as just instructing the computer what to do, just at a high level, right? So when we talk about these instructions, they have two ways of being executed by the computer. And roughly these break down into what we call interpreted languages and compiled languages. So that the code that we write, which is representing the instructions that we write, can be executed in one of these two ways. Let me start with the left. So the interpreted languages, this means that the computer is literally executing the instructions line by line by line when we run the program. So there is no translation of anything. It's just literally taking our instructions and running it line by line, instruction by instruction, essentially. Now, the advantage to doing this is that it's easier to debug because the instructions are going to be executed one by one, so it can hit an error pretty quick. If there's a mistake in one instruction, nothing else will run. However, it's also slower because we're going to take it one instruction at a time. And so this way of running programs tends to be slower, but it's also easier to work with, which is why we're so interested in Python. It's in this bucket of what we call interpreted languages. So a lot of scripting languages find themselves in this bucket of being executed one line at a time, no translation needed by the machine. It just reads our instructions and executes it. The thing that does the execution is called an interpreter. And Python has an interpreter that we will get you guys set up with on your own machine that can execute Python code. So you need an interpreter. The interpreter just executes your instructions line by line by line. So some examples would be like Python. That's what we're going to study in this entire program. But there's other languages like JavaScript, Ruby, Perl, many others that are interpreted. They require an interpreter, but they execute line by line by line, and there's no intermediate translation of anything. It's kind of executed as is. Now, contrast this with compiled languages, which are kind of a different beast. These instructions have to be translated into something the machine can understand in order to execute. So there is an intermediate step of what we call compiling the code into basically a translated version of your instructions so that the machine can execute it. Now, there's a trade-off there. Doing that can make it more difficult to develop, and it can take longer to debug because you have to go through this translation step every single time through the compiler. But when you run the code, because it's already been translated into this machine format, it's a lot faster. So some examples of languages like this are C, C++, Java, Go, but we won't really be working with those. We'll just be sticking with Python. But if you have experience with those languages, you're probably familiar with this. You have to compile the program first before you can execute it. But we are going to be in this interpreted world, if and it's okay. Like, if none of this makes sense, that's okay. Just understand that generally interpreted languages are going to be more user friendly because they're easier to execute. They don't require as many moving parts as what a compiled language would require, which is nice for us, right? Nice for Python. That's what we're going to be interested in working with. Kind of. Yeah, they're kind of related. So the question is, are JavaScript and Java related? Kind of. JavaScript is kind of like the scripting version of some of the same concepts we see in Java, but Java is the compiled. It requires a special kind of what's called a Java runtime, which is a compiler to translate the Java code into machine code that the Java runtime will execute. JavaScript is not like that at all. It can actually be ran in a web browser, which is JavaScript usually powers a lot of like front end websites. They're usually powered by JavaScript, and Java usually powers more like back end applications, like actual software programs are usually would be coded in Java. JavaScript is going to be used more for like building a website. But, I'm not an expert on that really, but that's kind of my understanding of it. And if anyone is an expert on those differences, feel free to let us know in the chat. But uh, that's my basic summary of that. Okay, so we have interpreted languages. That's where Python falls under. So it just summarizing that, it's going to be easier to work with those, which is great for us. That's another reason why Python's so easy. It's interpreted, meaning that everything executes. We don't need to worry about compiling things, which is nice. But also in terms of programming, there's also categories of how the instructions are written that you can bucket different languages into. So, for example, some language are more procedural in nature, meaning that you write out all the instructions exactly, kind of line by line by line. You don't really organize things at all in your instructions. So some examples would be like C and Pascal are more like that. Then on the opposite end of the spectrum is kind of object oriented, in which case you build your code and organize it around the idea of everything being an object. And so Python actually falls into this category where most things in Python are objects and you manipulate objects, and objects have data to them. They have things they can do and interact with other objects. So think of it just as a way we will organize our instructions. Python allows us to organize it around the concept of an object. We'll learn about what that means as we go along, but just realizing that some programming languages break down along these um, kind of buckets here. Python is also a scripted language, meaning you can write out your code in an individual script, and you can have an interpreter that executes that script. So you don't need to organize all your code inside of an object. So for that reason, Python, super flexible. That's another reason why it's so nice to use. It actually falls into both of these buckets on the right, which is very convenient. We can have, basically this means we can have a lot of organization or very little organization, depending on how we want to set it up. Yeah, Roberto. So even though they're different types, so Java is compiled and Python is interpreted. They are both object oriented, meaning, so think of this slide as telling you how the instructions are organized. So how they are executed is different. So Java requires a compiler to execute things. Python requires an interpreter. This is more about how the instructions are organized. So Java and Python both allow you to organize your code into objects. But what's nice about Python is it also falls under the bucket of scripting, meaning that it allows you to organize things into scripts, which is less organization than it would be into objects. We're actually going to learn about objects later on in a future lesson, like how to build objects and what they mean. So yeah, even though they're different, they're both object-oriented, which just means that you can organize your code into objects. Python allows that, so does Java, so does C++. Many languages allow for organizing your code into objects. So we're going to learn about that. It's not that one's better. They're just I would put them at different. So let me draw this. I would put them at different ends of the spectrum on organization. So scripting is very loose. Basically, it's more like an individual set of instructions to do one task. You can just have, and you can have many individual scripts to do many small tasks. And then on the other end of the spectrum, think about it as like you've organized your cabinet into many folders and many like many pieces of organization that are we would call objects. So object-oriented programming, OOP, is kind of on the other end of the spectrum when it comes to like level of organization. Does that make sense? So scripting very loose. Usually scripting is reserved for like one task, and it's you're just writing out your instructions to accomplish that one task, which is helpful for like automation of things because you're usually automating like a single task. So it's very loose. It's not very organized, and nothing is organized necessarily in objects. Very loose organization. Object oriented is much more structure to it and things being put into objects in order to manipulate and work with objects throughout the program. Yeah, it's not that one's better. I think it's more just use case dependent. Um, there are times where it actually will benefit us from using objects. And I think the thing to pay attention to on this slide is that look at where Python falls into. It actually falls into both, meaning that we can have things very loose and easy to work with because scripting usually will be faster and easier to just write something to accomplish one task. But we have the flexibility to organize our code into objects if we want to, which will be better for bigger tasks that require more organization, like training a neural network or building an LLM. Those bigger tasks would benefit from more organization. And then finally on this slide, there are languages that are built on the concept of their entire way of writing instructions is more in a functional way, meaning everything is based on operating functions and variables. And so there are some languages like that. Haskell and Scala are very popular ones. But that can be very difficult to learn. It can be difficult, but very nice in some ways because it can be very natural to think of you manipulate, like giving instructions to the computer in a functional way. Think about it as like applying a function to a variable. That makes sense, but writing all of your instructions in that way can be kind of difficult to learn. So for that reason, I think these languages are more difficult to learn, but they can be very powerful. And they find themselves very useful in like operating on big data. So have you ever heard of like Spark? Spark operates with Scala, for instance. But we won't really focus on functional. It's kind of its own paradigm. But again, like Python is where our focus will be. It allows us to be really organized, loosely organized. Nice flexibility there. So far, based on these two slides, I'm showing you that Python is interpreted, which is easier and faster to work with. Not faster to run, but faster to get up and running because you don't need to compile things. That's nice from our perspective. And it also has very good flexibility when it comes to organizing our instructions, organizing our code. It could be very loose in scripts, could be very structured in objects. Okay, so generally, no matter what language it is, when you process those instructions, generally things are going to be organized, even if it's in a script or if it's object-oriented. You're generally going to have the very beginning of the program kind of setting up the input, then the middle of it really processing that and doing something with that. So that's usually like the bulk of the logic is in the processing phase. And then generally you're producing some output. So that could be like a model prediction, that could be a graph that you've built from your code, whatever that output is. But generally it flows this way. This makes sense, right? Of course, there's input, you're manipulating that input in some way, and then you're producing some output. I think that all makes sense. That's a very logical way to flow. Now, that's not to say that within this processing step, there may not be iteration. Like, of course, there may be times where we need to, as part of the processing, kind of iterate and do multiple passes of processing. So the processing could be a lot. We could be doing a lot. We could be doing a little. Just depends on what we're actually doing. So if we're reading in some data as the input, and then we're just doing some simple slicing and dicing of it, that's some easy processing, and maybe producing a graph or producing a metric, something of that sort. That's pretty easy to do. But if we're training a neural network or training a model, the processing step can take a while and it may, be very iterative in nature. So it just depends on what we're doing and those instructions. But no matter what, most of our programs will flow in this way, kind of input, processing, output. It makes sense. It's very logical. So what are some principles that we should abide by when we're writing our code? So this would really be for any language, but of course for Python that we are interested in. So something we're going to be interested in doing is basically avoiding repetition where we can. So instead of having copy paste everywhere, we will generally favor organizing our code to some degree, meaning we will utilize functions where it makes sense and objects where it makes sense to organize things. And also, instead of having very repetitive code, we will favor using loop structures that can iterate over things many times instead of us having to write all those out one by one by one. So we're going to learn about these tools that we have at our disposal, but they will help us organize our code, avoid repetition all over the place. One of the things we want to avoid is having the same code repeated all over the place. If we find ourselves doing that, we should really put that code into a function or maybe into an object so that we can reuse it. So we're really going to favor like reusability of things, recycle, reuse. So we're going to learn how to do that, how to build functions, how to build objects, but that's something we're going to favor when we're programming. It's something you should be on the lookout for. If you find yourself writing the same code over and over, just in different spots, that's probably a clue. You should organize that into a function so you can just call that function wherever you need to rather than copying all that code. Okay, so we're going to avoid repetition. Now, the reason we're going to do that is to keep everything simple. We want to make sure things are clean, simple, understandable. We don't want to have overly complex things that are very difficult to follow. So one of the things that is going to be really nice about Python is it lends itself very well to being simple because it's going to be so easy to actually read and understand what's going on. But one of the things that falls in line with this is like, for instance, naming things appropriately. So instead of just calling everything in our code like X, Y, and Z, if somebody comes along and reads, oh, I see your code has an X, Y, and Z, that may not make sense. We would want to be more thoughtful with the names of our variables and names of our functions. So instead of XYZ, maybe we would use something like name or place or something appropriate to identify this is what this is. So think about that when you're writing your code is try to make it understandable. Name things that somebody else reading it would understand what it is if they see that name. So that's a mistake I see a lot of people make when they first start. It's okay, like when you're first getting started and practicing to name things like X, Y, and Z. I think that's fine, or like ABC. But does that make sense? Like if somebody else was reading it, they see XYZ in the program, that may not make sense. So, but if it has a good name to it, you could say, oh, like I see this is somebody's name that this variable is referring to, or this is a particular object that this is referring to. It's not just kind of an abstract X or Y or Z. Yeah, no spaghetti. Yeah, that's what a lot of people refer to that as. Just sloppy, unorganized, hard to understand code. One of the things that's great about Python is it's naturally very understandable. So like I don't think we will have that issue as much as if we had other languages, but it's still possible. So these are things we'll learn as we go along. I'm just trying to get it into your mind a little early here. Name things appropriately is one of the main pieces of advice I can give here. Um, so the next tip is to organize things. This goes along with avoiding repetition. So organize. Let's put things into functions. Let's put things into objects where it makes sense. If we know we're going to reuse that, let's put it into a function. And so we're going to learn about how to do that. But generally, this is good practice. If you find yourself writing code to do something and um, it turns out to be something you know you're going to reuse, or it turns out to be more than a handful of lines of code, generally want to organize that into a function so that it's clear this is what this code is doing, this is what it's responsible for. It's obvious, that it's organized into that unit of work, essentially. So we are going to practice this. This is something we're going to get good at, I think, as we go along, because we're going to favor organization where it makes sense. Okay. So readability, one of the things is using meaningful names. I kind of already mentioned that. The other thing is using good comments. So we're going to learn probably today how to make comments in our Python code, which is going to be helpful to orient yourself or another reader of it to, hey, this is what this function does. This is what this line of code is doing. I can't tell you how many times, people write code and then they themselves come back to it a week later and have no idea what it's doing. That happens all the time. It's even happened to me. So comments are your friend in that regard, and that they don't really cost you anything to put comments in there to say to kind of highlight this is what this piece of code is doing, and you can make a note to yourself right within the code. That's what comments are. They're basically notes to yourself. Um, so we're going to learn about that today, how to write comments and what that looks like in the code. The other thing is indentation. Python supports like you have to indent, so that's not really going to be an issue. Some languages don't really support that, especially the compiled ones. They don't enforce strictly indentation. They enforce other things like braces and semicolons and such, but our Python code will be properly indented by necessity because otherwise it won't work. So that's something we're going to learn about too today is how we indent things and why that matters. We'll talk about that. Um, I see a question from Sherry. Is Python a program that can be programmed with simple language? Yes, it's very easy to. Uh, it's Python is a very natural language to program in because, yeah, it's very simple. Simple language is used all over the place. I think it's going to be really easy to learn. I think it'll be really easy to pick up. At least that's my hope. And I think from my experience, it is. As I said, I was someone who did that, and I've worked with many learners who've done the same. So, yes, I think it'll be pretty easy to pick up. Very simple. Um, and then the other thing is we can find our errors very quickly. Now, because this is an interpreted language, we can run things one line at a time, and we will quickly hit errors early on in our code if we have them. So this will be nice. And Python provides really good error messages to say, hey, like this is what's wrong with your code. You should fix it this way. Essentially, like giving you a clue into what needs to be fixed. So this is something that we will practice with as we go along is kind of finding errors and what to do with them. But because it's interpreted, we will run across those very quickly, unlike with compiled language, which is harder to debug because you basically have to compile everything, hope that it compiles. If it does, then you have to run things. It just takes longer to get through that debugging phase. But with Python, it's very quick. You get a very quick feedback loop on if your code's working or not, which is nice. A lot of votes for C. I agree. C is the correct answer here. So the interpreter is the thing that will execute the code line by line. So it doesn't do everything at once. It actually goes line by line, which is why you can stumble onto your errors quickly. Because if you're going line by line, and you have an error on this first line, you're never going to reach these other lines, right? It's just going to show you this is where your error is. It's on line 101 or whatever it is. And, it's going to show you where the error is. So it's going to go one at a time and execute those. Um, it's not going to convert the code into machine language. That's what a compiled language would do, not an interpreted one. Um, and they do require an interpreter. So D is just completely wrong. It's the opposite of that. It does require it. So the interpreter is the thing that is executing the code line by line. So what is Python in particular? So it is as we've already seen, an interpreted language, meaning that it requires an interpreter to execute it. It's going to be executed line by line by that interpreter. It has capability to be object oriented. It also has capability to be scripted, um, which is just in relation to how it's organized. One of the really nice things is it is what we call dynamically typed, or what you would say dynamic semantics. We will see what this means, but basically it means that we don't have to declare what every variable or every piece of data is inside of Python. We can let the interpreter interpret that, which is nice. It makes things really easy to work with. We don't need to say, okay, this is an integer, this is a floating point number, this is an array, this is, with a lot of programming, especially compiled languages, programming languages, you have to do that because you have to tell the compiler this is what this piece of data is. But with an interpreter, the interpreter can, as the name suggests, interpret that. It doesn't need to know what everything is in terms of its data type, which makes it really easy to code. On the cons of that, it can make it more prone to error because you're not really enforcing types. So there is somewhat of a trade-off there, but for our purposes, the dynamic semantics make it so that the interpreter can dynamically understand what data is based on how it's being used, which is great for us. Like it makes it just quicker to get up and running and started and working with data. We don't need to declare what its type is, which is static semantics. Um, Now, Python itself, amazing programming language that's used across many different applications, such as data science, automation, machine learning, AI. It's also used in to build software even. I'm not sure if you guys know this, but there's some really famous software that's written in Python. One of the most famous is Instagram at Meta is completely coded in Python, which is it's over like 20,000 lines of Python code, which is pretty amazing. But so of course it's been really heavily used in AI and machine learning and such, but it's also as a programming language been used for other things like more pure software applications, which is what makes Python really nice is it's so simple, so easy to learn. So for that reason, it is going to be great for us to get started with, especially if you're coming in with basically no programming experience. The other thing about Python is it has, as I said earlier, like a really big ecosystem, meaning that there's many different packages and modules within those packages that do things already. So what's great about Python is we won't need to reinvent the wheel on so many different things. Like if we need to build a plot, if we need to train a model and use a specific type of model, that likely already exists in a package somewhere. And what's great is they're almost always open source, meaning we don't have to pay for anything. You can just use it out of the box, which is fantastic. So within Python, there's so many ways to do things, especially in the AI and machine learning world, that we'll just borrow those and use them in our own code, which helps, with getting up and running very quickly. We don't need to reinvent things. We can just use things that already exist, which is fantastic. So that ecosystem really benefits machine learning AI, because they already exist. We don't need to spend our time rewriting all those things. And so that's something we're going to learn as we go along, is like how to install those, how to import those, how to use those in our own code, those packages that already do something for us. So we don't need to come up with it on our own. We just need to use it properly. Okay, so there's a little bit of history. Python was first invented in the late 1980s by a guy named Guido van Rossum in Amsterdam. Where it gets its name is after the old comedy series. You guys might be familiar with it, the Monty Python Flying Circus show. Um, and so that's where it's got its name. It was first created then, but has since taken on a really big role in the, especially, I keep saying in the AI community, so much so that it has its own software foundation that kind of is responsible for maintaining it. They meet regularly, they come up with improvements, they come up with new versions of Python. For example, Python 3.14 just released in October, which is a major release. They hadn't had one in a while, and that one is 3.14, so it's kind of known as Python, which was a big milestone. Um, but they've had many different versions over the years. It's been maintained and developed by the software foundation. Um, and people are actively working on it at many large companies. So, for instance, Meta has a big group that is working on Python improvements, Microsoft as well. Google, all of those guys have groups kind of working to improve Python because they all use it. And so, what they typically do is work on it, open source it, and then the community gets to use those tools, those packages, those tools, those improvements. So it's actively utilized across many big companies, actively maintained by them or contributed to by them. So that's really great. Um, Python was originally derived from language, um, other languages, as kind of a trying to find like a mixture of some of the best of all worlds. But its main like driving force in why Python came to existence from these other languages is its ease of use. People really wanted something like super easy to get up and running and something really natural. And so as we start learning the syntax of it, I think you guys will understand why it's so easy. But that's what led to the inspiration, is just people wanted something easier to work with, not as strenuous to kind of get up and running. What open source license is it? That's a good question. I think it's the MIT license, but I could be wrong on that. You could look it up. If you go to python.org, yeah, if you go to python.org, I think it might talk more about what the license structure is there. I want to say it's the MIT open license, but I'm really not 100% sure on that. Okay, so what are some of the benefits of working with Python? And these are things you will experience as we go along, but just wanted to call them out. The flexibility of it, as I said, it can be really organized into object-oriented, or it can be loosely organized into scripts. So that flexibility alone is really awesome, which has allowed it to power many different things like APIs, web pages, full-blown applications like Instagram, um, chat GPTs, like actual AI, LLMs. It has so much flexibility there to power so many different applications. Probably the biggest benefit, especially to us, is its ease of use. Uh, oh, thank you. Tim just posted it. It's the GNU public license. Yes. Oh, never mind. It's a Python software found. It has its own. Okay, perfect. Thanks for sharing that. Thanks for sharing that. Yeah, I wasn't completely sure which license it was, but it is open source. And people do make their own kind of derivations of Python. But as I was saying, one of the benefits of Python is how easy it is to learn. I keep emphasizing that because it's true. Once we get into it, you will see this, I promise. It'll be easy to learn, easy to pick up. Um, and it's designed in that way, designed to be very minimalist as a language, which is great. It has a lot of things that come with it, and it's kind of built into Python, a lot of capability. So we call that the standard library. It's just the things built into Python. It has a lot of capability out of the box. Um, not only that, but it has a large community that's developed so many different packages that do things for us, especially in the AI world. So that's another great thing, kind of a robust community developing these packages that help us get things done. Um, Readability. So because the code is so simple, it's also easy to read. So you can usually read other Python code and quickly understand what it's doing, which, makes for um, easy understanding of other people's code, easy understanding of code in the community, and kind of almost like it's self-documenting because it's so easy to read. So that simplicity, that ease of use lends itself well to being really readable. You can usually just take a look at the code, easily read it, understand what it's doing, which is great. Like great for you guys learning, great for taking a look at the demos and examples that we will do. They're very readable. Okay, so why has Python really dominated AI? So this is a valid question. Like even so it's used for many different things. It's a programming language, so it can build applications. And I've given you the example of Instagram, and there's many others that are built off of Python code. Why is it so useful for AI in particular? Mainly, some of the reasons we've already talked about, mainly how easy it is to use, lends itself well for AI because that has allowed people to kind of quickly get up and running and test out their algorithms, test out their models just really quickly with Python. That's great. The other things listed on here are certainly big reasons as well. So, for example, it has so many community libraries, those packages that have AI models and AI tools that we can reuse. That people have built these up over years and years and years. So it's to our benefit to reuse those and not have to reinvent everything. We can get quickly up and running with those, which would be great. The other thing is Python, it lends itself very, very well to working with data. In general, very easy to work with data, very easy to load it in from external sources, query it, work with it, visualize it. Python is so adept at that. So that's what makes it really nice at doing machine learning and AI because so much of it is manipulating data. So for that reason alone, Python is so popular in the AI community just because of its ability to work with data. It's so easy. This is something we're going to really focus in on, like in our next course when we talk about data science. But just the ability and the power of it to work with data lends itself well to AI capabilities. The other thing is I mentioned the rapid prototyping. You can quickly build a model in Python because the code is so easy and there's so many libraries already. You can quickly prototype. Um, it has obviously a big community around it that's building out these packages, writing documentation, maintaining it from an open source level. So that's another reason it's very popular. Python's also used with other technologies. So it does have capability to integrate with other languages. So for instance, one of the most popular integrations is Python can work with C and C++. So sometimes that's necessary to integrate with those to do certain things. So Python has been extended to work with other languages. So sometimes there's other necessary support from other like things in other languages that are necessary to power something in AI. For example, working with GPUs and doing things in deep learning, um, there's been a lot of integration with working with C tools. Now, will we do that? No, it's already been done for us in some of these packages, but the pure ability of Python to do that is really powerful, and it gets taken for granted, honestly, because you don't see that. It's underneath the hood, and it's abstracted away from you when you work with those Python packages. But there was a lot of work that went into it to integrate it with other programming languages. Okay. So as an example, like I mentioned the Instagram one, so Netflix, for instance, all of their recommendation is powered by Python. So when you open up Netflix or really any streaming service for that matter, they're going to use Python to deliver those recommendations and produce those personalized recommendations. Spotify as well for like music. Nearly all recommendation algorithms are written in Python. And in this program, we are actually going to learn about recommendation systems. So that'll be pretty fun. Way down the road when we get into machine learning, we'll talk about how do we build a recommendation engine, but they're all done through Python, for example. So really cool use cases there. So one of the things I wanted to address is how AI itself is changing coding. So you guys may be aware of this, but obviously there's been a huge kind of explosion in generative AI tools that can help write documents and write emails and write text and all these things. One of the things they can do is write code. So one of the big areas where AI is changing coding is its ability to generate code for us. And so throughout this program, like we won't shy away from that necessarily. And I encourage you guys to use AI tools as you see fit to help your own understanding and help your own productivity. Um, we still will go through the fundamentals so you can understand it, but the AI tools can definitely be a supplement to help. It's just that I think you guys will understand it better going through the examples that we do together. And so that when AI generates code, you will be able to understand it and also be able to debug it, right? Because it's not always going to be perfect. So that's always the catch with AI is that, it doesn't always produce perfect answers. But at the very least, we will be able to, debug things and understand things better so that uh, we can catch those errors. So obviously, like AI is also, besides flat out generating it, it's also suggesting what should be there. So some of the code editors really do a good job at that, suggesting things, picking up on what you should produce next. That's going to be very interesting as we get into some of the platforms that you guys will work with to write your Python code. They will have that ability. Um, so the other thing is like there's some cloud tools that don't require writing much code at all, and they can just do things. So in other words, you can power them by prompts. You're not really writing code, you're just writing natural language, and then they do something. They generate the code in the background and they execute something. We will learn about those things later on in the program, especially because we will cover generative AI in the future towards the end of our program. So if you're wondering, like, are we going to cover LLMs? Or are we going to cover how these things get generated? Yes, it just will be later on in the program. Okay, a lot of votes for B. Yeah, pretty unanimous on B. I think I agree with it. Yeah, B is definitely the right answer. So all of the recommendation systems, which we will learn how to build ourselves later on, are written in Python, and they are machine learning models that make the recommendations. And that machine learning is driven by data, and all of that data is manipulated in Python um, and used to train models that do the recommendations. That's all happening in Python. So we're going to talk about getting you guys set up on your own machine and talking about the different development environments we can use to actually work with Python code. Before we go into that, any questions about anything we covered so far? Everything's good so far. Yep. And if, again, if you have experience in Python, I recognize that it is going to be a little slow in the beginning. It's mostly to get us really oriented to some background around Python and get us set up. And then we will be doing, getting into the syntax and all that coming up shortly. So we will actually be learning Python specifics coming up soon, but we're going to get everything set up first. All right, so let's continue then. Thank you guys for that. So it turns out that there are many tools in the community for developing Python code. And so you might hear this word IDE. It is short for Integrated Development Environment. This is a piece of software that helps you write and test Python code. So, and there's many out there. There's a bunch on this list. We are going to focus on a few options. There's even more than what's on this list, but we're going to focus on a few options. These IDEs are designed to really help you write Python. They provide many tools in the background that make your life easier when you're working with Python. So for example, they can provide syntax highlighting. They can tell you when you have a syntax error, almost like a spell check for Python. They can help you run Python code right within the window. They can help you organize your projects. They can do a lot of different things. And so there's many tools out there that can do it, and it's really a personal preference which one you use. But in this program, we're really going to focus on a few of them to showcase those options because they're very popular options. And then allow you guys the flexibility to choose which option makes the most sense for you. So generally, that's going to be mostly a preference, mostly a preference as to which one you're the most comfortable with. But I want to give you guys the option to explore the various options that are available. Roberto, is there one that stands out as an industry standard? There's a couple that you see, like honestly, the two of them that we will study in this coming up in the next few slides are the industry standard, which are going to be VS Code, Microsoft VS Code, and then Jupyter Notebooks. So these two are going to be ones that we will study in particular and use throughout. So yes, we will. Those will be industry standards. PyCharm's also very popular. So I don't want to rule out PyCharm. I know a lot of people who use it. So I would encourage you to explore PyCharm as well if you want to, but we are not going to do that in these slides. But I would check it out and see if you like it. It's another very, I'm putting an asterisk next to it because I think it's one of the more popular. Yes. Yeah, we're going to do descriptions. Requirements, I'll try my best to give those, but honestly, the requirements will be given when you install them. So the other thing I want to say is we will have a couple of options that don't require you to install anything. So I'm going to showcase those as well. So there's a couple of options that are, we won't have to install anything because they're going to be cloud-based. Okay, I'll show you those. Okay, so but yeah, VS Code, I think VS Code and Jupyter Notebooks are probably the industry standard, most popular IDEs. Okay, so what we would recommend in this program and the ones that we will use the most throughout are going to be these three: Visual Studio Code, also known as VS Code, Jupyter Notebooks, and Google Colab, which is um, Google's hosted version of notebooks, essentially. So I will showcase each one of these and give you some examples of how to set it up and examples of how to work with it. And that's what we'll do over the course of the next few slides and the next bit of time. is I'm going to go through each one of these and kind of show you what you would need to do to get it set up. Now, that being said, excuse me, these two are ones that you will install. These two you would install locally on your own machine. And this one is cloud hosted by Google, and it's free. All of these are free, but the first two, VS Code and Jupyter Notebook, you would install on your own machine. Colab, you would just access through your web browser. It is hosted by Google. So that's an advantage. You don't really need to install anything. And for that reason, sometimes we will favor Colab, and for other reasons too. Colab has some really nice features if you've never used it. But notebooks, Jupyter Notebook and Colab are very similar. They're very similar. Colab just has its own spin-off on the notebook type of file that Jupyter Notebooks work with, and it's like I said, kind of cloud hosted. So I'm gonna walk us through each one of these and explain to you what they do, what they look like, and then we will I'll set up each one of them kind of in a live demo so you guys can see. Um, but we throughout the program, it will really be up to you which one of these you want to use. There's no hard requirement to use any one of them. It's really going to be your preference which one of these tools you want to use to work with Python. Whatever one you feel comfortable working with, that's the one you should use. All three of these are very popular in the industry, so you're not missing out by using one versus the other. They're all very popular. Even Colab, I know it wasn't on the screen, but it is widely used in the community and the industry. No system recommendations for training LLMs. No, because we won't really focus on that until the end. When we get into generative AI, we'll talk about that. When we get into generative AI, we'll talk about that. So yeah, we're not focusing on LLMs in the beginning. That's an advanced topic for us. What is my personal preference? Um, I like Visual Studio Code, personally. I That's what I use for my day-to-day work is Visual Studio Code. I like Visual Studio Code and I like Colab a lot. Um, so, we'll talk about this, but one of the advantages to Colab is that it has free access to GPUs, which is huge for doing things like neural nets. Um, so we will lean on Colab quite a bit uh, later on when we actually get to deep learning and neural nets. Because Colab has free access to GPUs. I'll show us that. It's really nice. And when you do anything with neural nets, it usually benefits you to have a GPU access. Um, so that'll be nice. But I usually do most Python coding inside of VS Code. It supports Python pretty well. What is more commonly used in the industry? The two most popular are Visual Studio Code and notebooks, Jupyter notebooks. They're both like you can't go wrong with either one. Those two are really popular. Jupyter notebooks and Visual Studio Code are really popular. There's both of those you would be okay with either one. Let me start with Visual Studio Code. So now Visual Studio Code is a more general code editor. So it's actually, you can edit lots of different languages inside of VS Code. So you could do Java, you could do C, you could do Scala, you can do Go, you can do all kinds of languages are supported inside of Visual Studio Code. So it's a really fantastic product for programming in general, not just Python. It has built-in terminal support. It has Copilot integrated into it, which is nice for AI, like generative AI assistance working with your code, which is nice. Of course, it supports Python, which is what we are interested in. It has Python tools. I will show us which ones we should install as part of VS Code so that we can work with Python files and notebooks. So it's a really great code editor in general, which is why I like using it. But in particular, it's pretty good at working with Python. It supports Python pretty deeply. So for that reason, VS Code is really, really popular. But just keep in mind, you can actually use it for many different types of code that that people write. JavaScript, Java, as I said, like many languages are supported inside of Visual Studio Code. So it's a more general code editor. It happens to be really great at working with Python, though. All right, so I'm going to show us a demo on setting up VS Code. Now, we're going to do this for each one of these. For Jupyter and for Colab, I'm gonna do similar demos. So don't worry, we'll get to those. But I want to start with VS Code to show you kind of how to get that set up and what it looks like. So where you can find this demo is inside of the demos that I mentioned earlier in the reference material. So I'm gonna jump over to that. Let me show you guys. So I'm back in the LMS. You guys will want to download the demos. I think somebody linked it earlier in case this didn't show up for you, but we're going to be inside of the demos and we're going to do demo 1 for lesson 1. We're going to do lesson 1, demo 1, which is going to be the VS Code demo. So the main steps that we're going to do is just going to be to point you to where to install Visual Studio Code. So it is an application, is a free application you can install on your machine. So you will want to follow this link that is within the demo file, this code.visualstudio.com/download, and download it for your particular platform. So if you're on Windows, obviously choose the Windows. If you're on a Mac, choose Mac, and make sure that you choose the right, one of the precautions is to choose the right Mac platform. So if you have like an M1, M2, M3, M4 Mac, choose the Apple Silicon button. If you're on an older Mac, then you want to use the Intel chip one. If you happen to be on Linux, which I don't, probably most of you are not, but if you are, you want to download the right distribution version. But follow this link first. That's the first step. Very easy step. Just go to that site, pick your right platform, and go ahead and download the installer. And mostly we will be walking through the steps in the installer, and then I will show us what it looks like once it's installed, and then show you a couple additional steps that are actually not mentioned in this file that I think are worth doing to get you set up. Yes, we will be doing Jupyter next. Yes. We're going to be covering VS Code, Jupyter, and Colab. I'm going to show us examples of all of those. Okay, let me ask you guys, were you guys able to get to the download page and start that download and installation of VS Code? Able to do that? Any issues with that? Okay. Yeah, it's just like any yeah, I love the optimism. Yet. Already having both of them installed. Okay. Yeah, no, if you already have it installed, I mean, great. I'll show. So if you already have VS Code installed, great. You can sit tight. I will show you a couple of extensions that you'll want to add for Python support. If you have it installed already, I'll show us how you can use it with Python in particular. Okay. If you already have it installed. Perfect. Looks like you have it launched. Still working on it. Okay. So these instructions show an example of someone that would be on a Microsoft platform, walking through the installation. If you're on a Windows, you probably want to create a desktop icon. You definitely want to add it to your path. And this just shows what's being installed. So this is all the install wizard on Windows, nothing that exciting there. So this, if you follow all these steps, you will have it installed. I hope you have enough disk space. I don't think it's too big. I don't think it's too massive. I forget how much space it takes. I don't think it's that much. I don't think it's that much, but yeah, hopefully you have enough. So if you don't, if you do not have enough disk space, don't worry because we're gonna do Colab, which doesn't require you installing anything. So you can always use that option. All right. So if for some reason, let me just say that too. Just even if it's not a disk space issue, if you have any installation issues, no worries because we will work with Colab and Google that is going to be cloud hosted. That you don't need to install anything. You just need a Google account. Okay, a free Google account. So no worries at all if you cannot get any of these things installed. Which are going to be Jupyter and VS Code. Where do we go? I haven't said yet. I'm just making sure it's installed for folks. I'm gonna go over to it in a second. But did we generally get it installed? And do you have it open? So if you get once you get it installed, uh, once you get it installed, then open it. Yeah, you need to get it installed. It should be this first. It should be this link here. Follow this link to get it installed. Oops, I pasted the wrong link. Let me find. I'll copy and paste the link. But yeah, take a moment to get it open. Once you have it open, just sit tight. If you want to, what does it say? Yeah, feel so for you guys seeing the Copilot features, click use AI features. I think that's okay. Yes. You'll likely want Copilot. Yes. Click click OK on that. That's the link, by the way, for the download in case we needed to get to it. Okay. So I'm going to go over to VS Code and show you what it looks like on my end. Okay, so you should have something that looks roughly like this. I don't have anything open. I don't have any files open. Just kind of have a blank screen here. But I would recommend using the AI features if you can. I think that'll come in handy later on. Are we comfortable moving forward? I want to show us the extensions that support Python. So right now, when you first install this, it does not work with Python out of the box. We have to install a couple extensions inside of here to get it to work with Python. I'm going to show us how to do that. Don't worry about tuning any settings. No, don't worry about doing any of that at this stage. Don't really need to tune anything. We just need to get Python support. Okay. So you guys with me on this main page? You can use your corporate. Sure. Yeah, you can use if you have it. If you have Copilot and want to use your corporate, you can use that. That's fine. But you guys are with me on the main page because I'm about to show us the extensions we need to install to work with Python. Okay. Really important because this is not in the documentation. Um, no need to reinstall. You can, and I'll show you how to add that through the extensions. No need to reinstall. You can add it as an extension. Yeah. Okay. So let me ask you guys, on the left, do you see this little box icon that if you hover over it says extensions? Do you see that? There may be other things here too, but at least that one with the extensions. Okay, so we do see that one. Okay. So what we want to do, no, I wouldn't uninstall. That's okay because we're actually going to install Anaconda to get Jupyter. I would cancel that if you can because you're going to want that for Jupyter as well. I wouldn't uninstall Anaconda. I wouldn't uninstall. But I mean, if it's already doing it, that's okay. We'll just reinstall it later. All right, so back to the extensions. So let's click on the extensions. Okay, so do we see something like this that has a search bar for extensions? Do we see the search bar for the extensions? Okay, what do you think we're going to search for? Python. Python. We're going to search for Python. Yep. So you are going to want to install the official Python extension from Microsoft. It is this one that has the blue check mark next to Python. So there are other ones here, but we just want the one that says Python from Microsoft. Do we see that extension when you type in Python? Do we see that one? So it should just say Python. It should be Microsoft. It's really popular. It has a lot of downloads, over 192 million downloads as an extension. It's from Microsoft. Okay, click on that. Click on that. And then you should see an install button. I already have it installed, so it says uninstall, but right here, there should be an install button. Install the Python extension. It's out of 192 million installs. Really popular extension. Are you guys able to install it? You want to install that. It should be pretty quick. It should be pretty quick. It's not that big of an extension. So what this does is just the Python, Sherry, it's just a Python one. If you go into the extensions and then search for Python, it is just the one, it's just this one that says Python and it's from Microsoft. Python blue checkmark Microsoft. You want that one. And then you want to click on that one and then hit the install. Roberto, is that for Copilot? Is that for Copilot? Maybe try closing it and reopening it. Try closing VS Code, reopening and retrying the install. No, we're not opening any folders right now. We're not opening it. We're just installing the extension. That's all. We're just installing the extension. We're not opening any project folders. Just installing the extension. Were we able to install that? I know there's a lot by Microsoft, but there should just be one that says Python. So see how the name, like this name here is iSort, this name is Python debugger, this one is Pylance. Just the one that says Python. Just that one. That's the one we want. Only that one right now. Okay, perfect. Perfect. Okay, great. Okay, so one more extension for you guys. So once you install that one, I have one more for you that you want to install. Are we ready for that one? One more we want to install. Okay, we're ready for the next one. So the next one you want to install is the Jupyter extension, which is the Jupyter. It's this one. It's the very first one here on my screen. So it says Jupyter and it's from Microsoft. Okay, we want to install that one. Jupyter and it's from Microsoft. Want to install that one. So this one has 98 million installs. You want to install this one. Did you guys find that one? So you want to type in Jupyter, and it should be the Jupyter extension here that is from Microsoft. So you want to install that one. Great. Now, what does this one do? This extension will allow you to work with Jupyter notebooks inside of VS Code if you want to. So Jupyter Notebook has its own standalone program, which we will look at next. But you can have those files, those Jupyter Notebook files, be compatible with VS Code and open them and edit them and run them inside of VS Code if you want to. So this extension gives you the flexibility to work with notebooks inside of VS Code. So you never have to leave VS Code if you want to work with notebooks. So this is a good extension if you really want to work with notebooks and stay inside of VS Code. Yes. When you install an extension, it might install a couple other dependency extensions. Yes, but that's okay. Those are required. That's okay. That's okay. All right. How do we feel? Good. Did we get those installed? Were we able to get those installed? Okay. Here is how we will test that it all worked. So we're going to do something really simple. Here's how we will test that it worked. Let me go out of here and back to our files. So out of the extensions, I just went to the top button where it's the little file icon. And I am going to go up to the very, very top where so you guys see on your VS Code window where it says File, Edit, Selection, View. I'm just going to create a new file. So do you guys see that where you say File, Edit, Selection, View? Click on File, and then click on New File. You should see what I see on the screen right here. If you see Python and Jupyter Notebook, then you know those are installed correctly. Do you guys see these options? Text, Python, and Jupyter Notebook? Great. So what that means is we can now create those kind of files in the future. We can create notebooks, we can create Python files, and VS Code will be able to work with those. If you don't see Python, that means your Python extension didn't install yet, or you didn't install it. So you want to go back to your extensions and make sure you installed Python. So go to this button over here, the extensions, type in Python, and then make sure you install this Python extension. Okay. So you're going to install the Python extension and you're going to install the Jupyter extension, which is this. And install both of those. Make sure those are installed. If they're installed and you still didn't see that when you went to File, New File, if you don't see those, then try exiting VS Code and relaunching it. Okay, try exiting VS Code and reopening it and seeing if you can make a new file. Okay, but it should be under at the top, File, and then New File. And then you should see those options, Python and Jupyter. Once you have those extensions installed, you may need to close out of VS Code and reopen it to see that. Okay, perfect. After you relaunched. Okay, perfect. Yeah, you may need to relaunch so that it can show the extensions. Yeah. Perfect. Okay, perfect. So that's set up for you guys. So perfect. It's set up for you guys. We will work with it in the future, but just wanted to make sure it was installed and set up. Once we start working with Python, I will show you guys how to work with it. But glad that's set up for now. What issue are you having, Ramiro? Is it not showing? It's not showing Python or Jupyter for you when you do File, New File? It's not showing those? You may need to exit VS Code and reopen it. Sunil, yeah, you can make one. We're not going to do anything with it right now. You're not going to do anything with it right now, but it's make sure you're searching for it with a Y. It's Jupyter. You have to search. So when you click on the extension, search for Jupy. It should be the first thing that shows up with Jupyter. It's this Jupyter one from Microsoft. Kernel, let me show us that later. The kernel, you have to have a Python interpreter. So you may need to install a Python interpreter to be able to run the kernel. So I need to show us that. But I don't want to get into that right now. Save what to? Oh, wherever you want on your own machine. It's up to you. It doesn't really matter, just wherever you want. It doesn't matter. It's up to you. All right. So what I want to do is I want to take a break because now, I said after 2 hours we'll take a longer break. Um, so we'll take a 10-minute break now. If you're still having any issues, we can try to get you set up at the end of class. But we are going to set up. So coming up after our break, we're going to take a 10-minute break. Coming up after that, we'll go and install Jupyter Notebook, and then after that, we will look at Colab. So you're going to have multiple options to run Python. Not so if this wasn't working for you, that's okay. We'll try a different route. Okay, we'll try a different route. I know Colab will work for you because that is hosted by Google and really easy to get working with. So at the worst case scenario, Colab will work for you. I know it. But we'll try to get Jupyter notebooks installed for you as well. But if you're having issues with VS Code, let me know at the end of class. We'll try to get you set up. Okay. If you're still having issues with it. But what we're gonna do right now is take a 10-minute break. So let's try to be back in about 10 minutes. Let's call it an even let's call it an even what will we be covering? Installing the other Python setups, so Jupyter Notebook and working with Colab, and then we will get into the basics of Python's the syntax. So we're going to talk about indentation, identifiers, maybe if we have time, basic variable types, data types. Yep. So we'll get into Python. We will get into Python today. All right. So let's jump over to uh, Jupyter Notebooks. So what's so special about Jupyter? Well, it turns out that uh, Jupyter is a platform for running what are called notebook files. So obviously, we just installed the Jupyter extension in VS Code, which will allow us to run notebooks in VS Code. But Jupyter has its own notebook platform, and that's what you will install in this setup. Notebooks are special. They are really great Python code files that give us the ability to execute isolated, what are called cells of code. So we can run one cell at a time and test and debug the execution of that single cell without affecting any of the other cells. So notebooks are great for running code live and interactive. When we do a lot of our demos in this program, they're all going to be in notebooks so that we can kind of run things one cell at a time. Um, uh, no, so without notebooks, you run like a Python script, like a Python file, which is a .py file, and usually you have to either run that through a debugger or run the entire script at once. You don't really get code isolated into individual cells, which is really nice with notebooks. The other thing is notebooks are easily shareable. So you can share a notebook with somebody else and they can open it and see all of your inputs and outputs in the notebook, which is really nice. Like all of the outputs get saved into the notebook, which is nice. So, and notebooks, especially in the Jupyter platform, are going to have all the data science libraries available to them. So, if you're people usually love doing notebooks for working with data. Really easy to work with data inside of notebooks and build things like plots. You can display your uh, you can display your graphs really easily inside of the notebook and then share your notebook so other people can see your graphs. So notebooks are really awesome, like interactive environments for running code. Um, and we will favor notebooks as our primary way of running code throughout the program. Now, where you open those notebooks, is up to you. You can open them in VS Code. You can open them in the Jupyter Notebook platform. Uh, you can open them inside of Colab and run notebooks in Colab. Uh, Notebooks are very, very popular. Why isn't running in notebooks the default? It's because not all code runs inside of cells. Like applications are not going to be well suited for notebooks. Like Instagram is not running in a notebook. It's more structured into actual Python files, and actual more structured programs are going to be not in a notebook. Notebook is more for prototyping and debugging and uh, executing small chunks of code to test it out. It's not for writing larger programs like an LLM application, like a chatbot would generally be in not in a notebook. It'd be in like a Python file. Cells versus class objects. So cells are just small. Uh, think of them as small little environments to execute our code. Class objects are actual chunks of code that define an object. They're different things. Yeah, different things. We'll learn about objects, and we will certainly see what cells are as we go through. I'm going to show you an example of a cell coming up when we install Jupyter. But let's go through the installation of Jupyter Notebook so you can see what a notebook looks like. I think that'll be helpful to orient. So let's go over to that demo. So this is going to be demo two inside of lesson one. So we're going to go over to that. Everybody has this one? Okay, perfect. Okay, so you're going to follow this instruction. Now, what this is going to do is first, no, this is not going to be anything to do with VS Code. This is going to be a different platform. This is going to be Jupyter. Where is this? This is the demos. This is demo two inside of that demos folder that we said to grab all the demos from your LMS. Does anybody have that demo 2 PDF they can upload? I think somebody uploaded all of them earlier, but if you have demo 2, want to upload it real quick. I don't have the PDFs. If somebody wants to share that. So they're different. So what I was saying is you can open notebooks inside of VS Code, and the thing that allows you to open notebooks in VS Code is the extension. So yes, if you're going to work with notebooks in VS Code, you need the extension installed. But you can use the standalone Jupyter platform to work with notebooks. It's up to you. If you like using VS Code, you can do it that way. If you like the Jupyter platform, you can do it that way. It's up to you. It's just a preference. I'm giving you guys options. That's my goal, is to give you options and let you guys choose what you're most comfortable with. Okay. And we're taking time to do that now in the beginning of the program, right? Because we're going to be doing a lot of Python examples coming up as we start learning Python. So it's valuable to spend that time now. I know it can seem a little slow, but I promise it'll be worth it so that you guys have options for running your code. Yes, thank you guys for uploading those. Appreciate it. Those are the demos you want to follow along with. Okay, so the first step here is going to be to install Anaconda. Now you may be wondering, what is Anaconda? I thought we were talking about Jupyter. And that's a valid question. Anaconda is what's called a distribution of Python. So Anaconda is a program, a collection of software programs that give you a version of Python with a bunch of packages, with a bunch of packages already installed. And then uh, one of those is the Jupyter package so that you can run Jupyter notebooks. And what Jupyter notebooks will be is a basically a web browser application that will open up a notebook editor in your web browser. So that's ultimately what we're going to do, but we are going to install it via the Anaconda distribution, of Python. So that's where we're going to start, is with the initial download of Anaconda. Oh, it's no skipped registration. Okay, let me open the link. I think there's a way to find it without having to do the registration. There's a way to get to it without having to do that. I'm gonna find it real quick. Oh, you can't. Okay, so if you can't install it, that's okay. We will be able to work with notebooks in Colab, and you can work with notebooks inside of VS Code. That's fine too. Yeah, I'm going through the registration process so I can show you the install. Okay, let me share my screen. Did you guys get to, once you go through the like setting up your account, do you get to this page? Do you get to this page? For those of you going through, yeah, that looks right for you, Ashish. That looks right. Do you guys get to this page though when you get through your like account setup? Okay, you got to this page. Okay, so then choose your correct Windows or Mac. Down, you want to be over here on the left. You want to do Anaconda distribution. This is what you want to do. So choose the right one. If you're on an M1, M2, M3, you're going to do the Silicon. If you're on an older Mac, you're going to do the 64. And then obviously, if you're on a Windows, you should be clicking over here to do Windows. But you want to do the Anaconda distribution, not Miniconda. Okay, so click on the installer for Anaconda distribution. Okay, and then let that install. Now, while that's installing, let me explain something about the difference between, I think it was asked earlier, what's the difference between Anaconda as the default Python? So Anaconda, as I was saying earlier, is a version of Python that has a bunch of data science and machine learning packages already installed for you. So it comes with a bunch of packages that are already installed. So if you use that Python has a bunch of packages built in with it that you don't need to go out and install. So Anaconda is a very popular version of Python for people to install that are working in data science, AI, ML. Very popular version because it already comes with a bunch of packages that you would use for manipulating data, for doing machine learning, or doing anything in AI. So it's a very popular distribution. It also comes with Jupyter, which is why we want to use it, because it comes with the notebook capability out of the box. Okay, so I'm going to launch. So when this is done installing, you want to launch the program that gets installed called the Anaconda Navigator. So it should install a program on your machine called the Anaconda Navigator. Do you guys have that? Did anybody get through and you have that program, the Anaconda Navigator? You don't need any advanced ones. You don't need any advanced options. Just the defaults, all the defaults should be good. Still downloading? Okay, I'm going to show you what the navigator looks like once you have it. That's okay. If it takes a little bit of time to download, that's okay. Basically, once you download it, you just have to click a couple more buttons and then you can access Jupyter. Okay. Let me share my screen and show you what you like once it installs, this is what it should look like. It's okay if it's taking a little bit of time. You should have something that kind of looks like this, which is the dashboard that has the different programs available to you. Do you guys see something like this if you have the navigator? Do you see something like this? Which is the like when you open the navigator program, you should see something like this that has a bunch of different you do, okay. It's if it's taking a little bit of time, that's okay. Yes, Na Anaconda Navigator is how you launch. Yes. Anaconda Navigator is how you launch it. So yeah, you want to open that. Now, the whole reason to come here is so we can launch Jupyter notebooks. So we can launch Jupyter notebooks. This is the program we ultimately want to launch. This is going to allow us to open notebook files, edit them, run code cells. I'll show you what a notebook looks like in a second. But once you have Anaconda installed, open the navigator and then launch Jupyter Notebook. It's just one extra step, launch the Jupyter Notebook. What that should do is launch the notebook. It should launch the web browser of your like whatever you have as your default web browser. It should open the notebook program in your web browser. So if it's Chrome, Firefox, Edge, whatever your default web browser, it's going to launch the notebook program in the browser. Okay. So I'm going to launch it and then I'll show you what it looks like. Again, if it's taking you a little bit of time, that's okay. Whenever it's done, how did I get to these icons? Just launch. Do you have the Anaconda Navigator program? It should be installed. Open the Anaconda Navigator program. It should have been installed with the Anaconda installation. All right, was anybody able to get to this? The Jupyter, this, so it should launch in your browser. Anybody able to get to that? Fantastic, fantastic. I'm glad some of you guys were able to get to it. If it's not yet, that's okay. Remember, when it's done installing, you're going to go to Anaconda Navigator and then launch Jupyter Notebook. That's what you're going to do. That's okay, Roberto. It's okay. All right. I want to show you guys a notebook. I just want to show you what it looks like. What I'm going to do is I'm going to open a notebook by going to new and then Python 3 notebook. So you can open a folder, you can open a terminal, you can open a text file. I'm going to open a Python 3, which is a notebook. So it's a notebook powered by Python. So I'm going to click on that, which will launch a new notebook in a new tab. And here I am in the notebook editor. So now I am in a notebook editor screen. So if you go, when you first launch Jupyter, you can navigate to notice that that notebook got created here where I currently am on my machine. I could navigate to documents, and then I could create a new file there, or I can make a new folder here and do it that way. But I am just editing this notebook right here within this current folder that I'm in. Okay, so do you guys remember when I said that code gets executed in an isolated cell? Do you remember that? this is what a cell looks like. And you can make new cells by hitting this plus button. So you hit this plus button over here, you can make new cells. So if you hit plus, 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 I'm making a bunch of cells. Now, what's really cool about cells, yeah, Tim just discovered this. What's really cool about cells is you can change them to be text or code. So if you change it to Markdown, I can write Markdown text in here to say, this is my notebook. And then if I run this, it's going to display as text. So if I run that cell, which when I'm editing it, I can click run and it will render that as text because I changed the cell type to Markdown. Markdown is just a flavor of text style. So otherwise, we can write some Python code. Now, what I want you guys to type, I'll type this in the chat to verify everything is working, is I want you to type print hello world. I want you to type that inside of a cell. And then hit run. And it should run that code. And you should be able to see that. Shift enter. Yep. You can, whenever you're on a cell, you can hit shift enter, it'll run the cell. That's okay. You can go back and watch the video. So this is being recorded. You can go back and watch the video. I know it's a little frustrating. It's still installing for you, but go back and watch the video. And I definitely encourage, once it's installed, to go back and try this, which would be just launching your Anaconda navigator and then launching Jupyter. If you don't have, by the way, if you don't have Python 3, you may need to exit your navigator and reopen it. Okay, you may need to exit your navigator, reopen it so that you can launch Jupyter again. Were you guys able to run this in a cell? For those of you that have Jupyter running, were you able to run this? Nice, and it worked for you? Okay, perfect. Perfect. So this is what I meant by this is an isolated cell. So notice that we can run this and it doesn't affect sure, I hear you. I hear you. Update the doc. I can how about I post it in our Slack channel. By the way, do you guys have access to the Slack channel? Okay, I can post it there. I can post the instructions to get there. Okay, I can post it in our cohorts channel. I hear you. You don't want to search to a 4-hour video. I hear you. I don't have the link on hand, but you can get to it through the LMS. So if you go to the LMS and go to there should be um a link to get to it within there. It should be like over here on the right. I don't have the link. I don't have the link to it offhand. Yeah, but there should be a way to get to it from the LMS. Yeah, there should be a banner here. I don't know why I don't have it, but should be there. Okay, so if you're just getting things installed, how do you get to here? You open the navigator. Open the navigator. Syntax is hello world. It's just inside of, it's just that. Print hello world. Open the navigator. Open the navigator, which looks like this. Let me share my screen. Okay, open the Anaconda navigator that got installed. Then click launch on the Jupyter Notebook program. So you should have this at least. You may have other ones. Click on this launch. Click on this launch, and then you can launch the Anaconda navigator. Okay. If it's a little stuck, that's okay. We're gonna move on. We're gonna go to Colab, which can run notebooks as well. So if it seems a little stuck, that's okay. I will post in our Slack instructions on how to run this. That's okay. All right. But what I wanted to do before we move on to Colab is I just wanted to show you, I wanted to call out a couple things about notebooks. Um, is that a couple things about notebooks. One is that notice that these cells are very isolated. Whatever I put here um, does not affect what I had before. So I can add numbers like that and it can compute that. And this does not affect this. So this is why notebooks are so great is you can document the notebooks with mixing in text and code like we do here. You can run code in its own cells. You can run code in its own cells, and then you can have that very isolated. So I could jump down here and run something, and that doesn't matter that there's nothing here. Like it doesn't need to be in order. I can, I can run stuff out of, I can overwrite this and run that, and it produces the output. Uh, so, many things we could do uh, inside of notebooks that are really fantastic for just quickly prototyping and running Python code inside of cells. So it's very nice that way. So notebooks are really nice. You can also like I could share this file. So this produces a file on my machine. If I go back to the navigator, um, Anaconda navigator, Cherry Anaconda navigator. Um, Can you read value of variables from another cell? You have to store them into variables. So I could call this x, and then I could refer to x later. We'll learn about that. We'll learn about that with variables. But yes, you can kind of do that with variables. All right. Um, what do the numbers after which numbers? These the ones in the brackets? Oh, so those are which cells we've executed. So I executed this one first, so it's number one, and then I executed this. I think I did this second, so it's text. It doesn't really get one of those, and then I did this one third, and then I think I did this one fourth, and then it get overwritten with the fifth. So it just tells you like how many executions you've done and which number execution that was. Then I did this one sixth. It just keeps track of your executions. Okay, so somebody asked about a kernel. What is a kernel? So the kernel is the kernel is basically the interpreter. So it's the thing that the kernel is just a copy of the interpreter that the notebook is attaching to in order to run. So the notebook can't run anything because remember, Python needs an interpreter to run its code. So in notebooks, we basically create like a virtual copy of the interpreter called a kernel. And you can actually have many kernels based on your base interpreter. So what's nice is um, Anaconda comes with an interpreter for you, and then you create kernels that are virtual copies of um, that interpreter so that you can run your Python code against it. Remember, you need an interpreter, but notebooks attach to kernels. Kernels are like virtual interpreters. And you can have many kernels based on the original interpreter. So the kernel is literally just think of it like the computer that's powering the notebook. That's all. It's just the compute engine that's allowing you to execute your Python code. So every notebook has an associated kernel. And what's interesting is if you restart your kernel, you lose all your data. So all of these outputs that we have, you would lose if you restarted your kernel. So if I restart, now since I restarted, this is not going to know what X is. So if I try to print X again, it's going to say, I don't know what X is because I restarted my kernel. It lost all that data. But I can redefine it and then there it is. And notice that my iterations restart. My iterations restart when I restart my kernel. So if I go back and restart the kernel again, and now if I run this, this will be first. So notice how that restarts to first. This will be second. This will be third. Try restarting. I don't know what that is. I don't know why that. Yeah, choose the Anaconda. Either one. Choose. You want to use Anaconda as your. But what that's saying is, what do you want to use as your interpreter to build your kernels? So choose one of those. That's fine. So yeah, Anaconda requirements, laptop requirements. You need a little bit of RAM. You need a little bit of RAM to run the notebooks because you need some memory. You don't need a lot of it though. I'd be surprised if you didn't meet the requirements. It's not that much, but you do need some. I'm not sure the exact. I'd have to look that up on the Anaconda website. Oh, it must have been full to start with, or pretty full. This doesn't take up that much space, I don't think. Was it pretty full to begin with? I would assume. I don't think this takes up that much space. What I want to do then, I want to go over to Colab. Okay, how do we feel about the notebooks? Maybe if it's still installing for you, give it a little time. Open the navigator. Let's try I guarantee you Colab will work for you if you're still having issues with if you're having issues with Jupyter, no worries. Let's just try Colab. I promise that will be a lot easier. Be a million times easier, I think, than working with Jupyter. Okay, great. So we will continue then. All right. Let me jump over to our final demo with setting up a Colab notebook. So I'm just going to jump into doing that in the interest of time. So would you be taking up additional sessions too, other than I'm going to be the instructor for all of the courses in this program. So you're stuck with me for all of those. Does that make sense? Like all of the AI engineer program courses. Yeah. Yeah, stuck or be excited. It's going to be one or the other. Probably not an in-between feeling. Hopefully cool. Hopefully good. Yeah. Like I said, I've taught this many times. Uh, I think it would be I think it'll be good. You are stuck. Okay, well, we're gonna get you unstuck with Colab. I would not worry about getting Jupyter set up. If it's not working for you, we're gonna ditch it and we're gonna use something else that works. I promise it's not a, I promise getting Jupyter set up is not that important relative to getting at least one of these options that works. So if it's not working over on Jupyter, I'm not worried in the slightest about it because there's going to be plenty of options to run Python code. In fact, we're going to do one next, which is going to be with Colab. So we'll do that. So let me jump into that. Let me share my screen here. Um, Learning a lot already. Great. That's great. Glad to hear that. Thank you. Okay. Thank you guys. Appreciate it. All right, let me go to the demo 3. All right, so what you want to do essentially is to go to this website, which I have here. I'm going to paste it in the chat. Um, so what you want to do is go to Google's website for their Colab platform, which is, so Colab is a notebook platform that Google hosts. So you don't need to install anything. You just go there in your favorite web browser, log in with your Google account. In fact, I don't even think you need to be necessarily logged in. You can in order to save your notebooks to your drive. But you go there and you basically open up a notebook and start working with it right away. And it's fantastic. Their notebook environment already has a lot of packages installed into it for AI and machine learning. So that's really great. Um, Once you get to the page, you should log in though if you have a Google account. The only reason I say that is because it will save your notebooks to your drive automatically, so that it will automatically save your notebooks just like as if you were working in a Google Doc. So that's great, so that it saves your work automatically. So please, I would recommend getting a Google account if you don't have one for free. Logging in using Colab is completely free. So it's a fantastic platform. Um, when you go to that site, assuming you've logged in, you want to click on that lower left blue button where it says New Notebook. You can see it in this screenshot, and I'll open up one in a moment on my screen. But do you guys see this screen right here that's in this screenshot that has the New Notebook on the bottom and the lower left? No, from that site? What do you see? Oh, so you're already in a notebook. You're already in a notebook, like it says "Welcome to Colab." Oh, okay. So it already opened the notebook for you. Okay, that's fine. That's fine. I'll show you. I'll show you what that looks like. That's no problem. That means you're already inside of it. Okay. Okay. So then we're pretty much in the notebook environment, and we can start running code. Let me hop over to Colab and show you guys what it looks like. Let me stop sharing that and jump over to Colab here. Okay. So if you're in the Welcome to Colab, that's fine. Or you can start a new notebook. Let me assume that we've opened up Welcome to Colab. So you're in this screen. What you want to do if you're in this screen is just go up to File and do New Notebook. Just go to File, New Notebook, and Drive. Just do that. File, New Notebook. And this will create a new notebook for you, which will start refresh a blank notebook. Okay. Were you able to do that? If you guys were folks able to get here to this blank notebook, one way or the other, you clicked the blue button to hit a new one, or you went up to File and did New Notebook. Yes. Okay. So there we are. Without doing all the Jupyter install steps, we're in a notebook. Look how easy that was, right? So why didn't we just start with this? Um, so yeah, so we're in Google's Notebook platform, which is a fantastic platform. And what's great about this is you can export these. Now these are .ipynb, which is if you're curious what that extension means, it's short for Interactive Python Notebook. Okay, IPynb. So these are the files that you can open in Jupyter. If you noticed when you opened up Jupyter Notebook earlier, it was an IPynb. Inside of VS Code, when you work with notebooks, they are IPynb. So IPynb is a notebook file, and it can be opened in any one of these three platforms, right? The Jupyter from Anaconda, the VS Code can open IPynb, and you can also upload your own notebooks here if you have them on your own machine. You just go to File, Upload Notebook, and then it will open up a box where you can choose which file on your machine to upload. So you can upload your own notebooks, which will be great when we get into demos. When we have demo notebooks for you guys that we'll work through with our code, you can upload those into Colab and work with them directly inside of here. So let's try running something. Let's do the print hello world. So you want to type that in, and I can paste it in the chat for you guys. And then you want to hit either Shift Enter or this play button right next to the cell. Okay. So that might take a moment because it's booting up your kernel. But then it should run and you should see the output. Now this is going to look very similar to Jupyter, just slightly different. We're inside of Colab and we started a new notebook. We're just inside of a blank notebook for now, and we are just within this first cell, and I'm doing hello world. Were you guys able to run that? We didn't, but we could. We could open a notebook in VS Code because we installed the extension. We did that. Remember, we installed the Jupyter extension. So we can open notebooks in VS Code and we can run them there. I just didn't show that to us. We might do that later down the road, but you do have that flexibility to run things there if you want to. Okay. One thing I want to show you guys that's really cool. So one thing I want to show you is if you go up to runtime and then go down to change runtime type. Do you guys have that? Change runtime type. So if you click on runtime and then change runtime type, do we have that? Click on that. Click on change runtime type. And look at our options. We can choose a GPU for free. So we can swap over to a GPU kernel, which is fantastic for training deep learning models, and we can use that GPU for free. This is one of the reasons that Colab is so amazing is they give free access to a GPU. So if you don't have one on your own machine, you can use the GPUs from Colab for free. Yeah, go ahead. I mean, there's nothing wrong with it. So what it's going to ask you to do is terminate your current kernel because you're connected to a CPU basic kernel. It wants you to disable that so you can swap over to the GPUs. Click OK. That's okay. All right. And then we are now, we click Save, and that will swap us over and connect us to a GPU. So how you know that you're connected to a GPU is if you go over to, if you go over to this box on the right, do you guys see that one where it says RAM and disk? If we click that, it will show us our resource usage, and you should see GPU RAM available at 15 gigs. So you have 15 gigabytes of GPU RAM available that you can use. So remember, you just click this RAM. You should click this RAM, sorry, this RAM and disk. Roberto, did you swap over the runtime to, yeah, it should pop up. Okay. Then you should be able to click on this. Yeah, it might take some time to connect to one because what Google has to allocate one to you, and then it has to like connect it over the cloud. It can take a minute. Yeah, it can take a minute. It has to allocate one to you. So the question is, which one is better? So for the vast majority of things, the CPU, the standard CPU runtime, which is the default, is going to be better for the vast majority of things. The only time the GPU is really going to be beneficial is when we start doing deep learning and training neural networks. Then the GPU will be really beneficial. It will speed up the training time by a significant amount. I can tell you, like, I trained a neural network for images, for image recognition. It took 2 hours on the CPU, and then when I swapped it over to GPU, it took less than a minute. It took less than a minute, and it was taking 2 hours on the CPU. So yeah, training neural nets on a GPU, when we get to that, is going to be beneficial. So if you're not using Colab right now, that's okay. But in the future, when you get into deep learning, you're likely going to want to use Colab to swap over to the GPU for free. Now, they do rate limit you. So it's free, but you can max it out in a day and then they cool you off for 24 hours, which I have done, unfortunately. So like if you max out that RAM and you use it too much in a 24-hour period, they will not allow you to connect to a free GPU for another 24 hours. So I doubt you'll run in that situation, but I have before. If you're just using it so much. No, so unfortunately, no. So unfortunately, no, you cannot. Colab doesn't connect to your local resources. It does the cloud, Google's cloud resources. So no, you can't use your own through Colab. But yes, you could use your own GPU through VS Code. I will show us how to do that later when we get into deep learning. I will show you that later. We won't need to worry about that now, but later on, yes, that'll be important. It doesn't show GPU. Make sure you swap over the runtime to go to change runtime type and make sure you pick GPU. Make sure you go away from. No, you should use Colab. You don't need to buy anything. You just use Colab. Just use Colab for sure. Colab's free. It does everything you're going to need for the class. Yeah, I highly advocate for Colab. So by the way, if you're curious, like Colab came about because Google wanted the machine learning research community to have access to GPUs for free to develop like machine learning and deep learning models. So it's been around for a while. I remember using Colab probably almost 10 years ago, and it used to be very lucky if you got a GPU. You used to have to click and then hope that you would get allocated one, and sometimes you wouldn't. And I would sit there and have to refresh and try to hope that I would get a GPU. But now it's like readily available, which is fantastic. No, you're joining it at a good time because I'm telling you the GPU was very difficult to get. I would always try to switch over to that, and I would rarely be able to. So pretty good. But like I said, like if the CPU is perfectly fine for everything we're gonna do, except when we get into deep learning, you're gonna want to swap that over to GPU. But that's gonna be we have a while till we get to deep learning. We have a lot to learn between now and then. Okay. What do we think? Do we like Colab? We're comfortable with it. Feel free to use it. Feel free to use VS Code. Feel free to use Jupyter, whatever you want to use. Okay. There's options, right? I hopefully you have options that work for you. They are all used in the industry, so you're not missing out on if whatever you use, people use it. Of these three, people use all of them. So feel free to use whatever is easiest. Yeah, I can show that real quick. Yeah, let me go back over to it. I'm going to be real quick on it though, because I want to make sure we get over to our other material. Okay, let me show you how you can run a notebook. Let me show you how to run a notebook. So I'm going to go to File, New File, and open a Jupyter notebook. Okay, so it'll open a new. Now notice the extension of it is .ipynb. That should be no surprise. That is the universal kind of interactive Python notebook file. Okay. So the biggest thing you have to do when you open a notebook in VS Code is you have to tell it what kernel to connect to. So you have to go to select kernel, and then what you have to select is the Python environment. And luckily, if you installed Anaconda, you have a built-in Python environment, which is going to be your uh, which is going to be um, the which is going to be the Anaconda that you installed. So I have Anaconda here. Now I have a lot of other ones, but the Anaconda is here. Let's say it's this one. Does that so when you yeah, you have to install a Python environment. Yes. So you want to install Anaconda first, and then you can run your notebooks. And then you just run your code as usual, and then we can run that. Yeah. But like it's working as if, the same kind of notebook that we have inside of Colab, the same kind of notebook we have in Jupyter. You have to have a Python installed for this to work. So you go to Python environments and then choose a Python environment. You could try to create one. I'm not sure if that'll work for you. Create Python environment. You could try that too. Yeah, that's fine. Anyone will work. Any Python will work. You just need to pick a Python. Anyone will work. Oh. Okay. Yeah, if it defaulted to something, that's fine too. And then we can generate more cells, can run cells. But yeah, that's the thing is you're going to want to install Anaconda most likely because you need a Python version installed on your machine in order to run this. Perfect. Okay. All right. So what I want to do is jump back over to our notes so we can continue along. Again, feel free to use whatever platform works for you. Colab, doing notebooks in VS Code, doing Jupyter notebooks, whatever works for you, please feel free to use that. There is no wrong way of using it. Whatever is best suited to you and you're most comfortable with, please use that option. It's lowercase p. That's why. Lowercase p. Capital P is not a function in Python. Lowercase. Yeah, go with Colab. Yeah, if you're on a machine you can't install anything, go with Colab. That's totally fine. That's why it's there. It's for the, convenient kind of cloud aspect to it. Um, Feel free to do Colab for everything. That's totally fine. I will use Colab from time to time as well. All right, let me go back to our notes then and pick up from syntax. So I'm going to go back to, let me share my screen, go back to, can you use Colab on your phone? I've never tried it. I would be surprised. Maybe an iPad, maybe like a tablet, it could work pretty well. Phone, I'm not so sure. Yeah, go ahead, try it and let me know how it works. Try it and let me know. I really don't know. I'm curious now to try that. All right. So I'm going back over the notes. We're going to finish up today with the time we have left to go through some syntax. So uh, really getting into Python, like the actual code of it, so we can get started on that and start working our way through it. Uh, the difference, so the difference is you will be executing .py files within the terminal. So you'll be running Python files instead of cells in a notebook. You're running a Python script rather than individual cells. Okay, so there's a difference there. And the reason we choose notebooks is to run individual cells. It's just easier. Same syntax. Same syntax, it's just the code is not isolated into cells. Still Python. All right. Um, let's go forward into the syntax. Start learning about it. All right. So something we need to learn about is how do we properly write Python code? What is the syntax to it? So some things we're going to need to learn about are how to write proper identifiers, which are names. Identifiers are just names for variables. So we need to know what's allowed, what's not allowed. We need to talk about what the indentation means and why do we need it in Python. I want to show you guys how to write comments because that's really important to leaving notes to yourself or others about the code. And then talk about generally how we produce output and how we can accept input from a user or someone interacting with our code. I want to talk about all of these things. We'll see how much of it we get to. But let's start with the identifier. So what is an identifier in programming? This is really for any programming language. An identifier is just a name we give to something inside of our code. So it's a name we give to a variable, a name we give to a function, a name we give to an object. So any name we give to something in our code, like when we set something equal to x, like x equals 3 plus 3, um, that thing, the x, is the name we are giving or assigning to a result or a variable or an object. So anytime we write down a name in our code of something, there are certain rules that those names have to follow. And these are something we will pick up as we go along, but I wanted to call them out here. So when we name anything in Python, generally they have to follow these set of rules, meaning they have to be a combo of lowercase or uppercase letters. Either one's allowed. It can be even be a mixture of lowercase and uppercase. Numerical digits are allowed in the name. That's okay. Any digit 0 to 9, it's okay. And underscores are okay. Okay, underscores are okay. And there's no minimum or maximum length. So names can be really long, they can be really short. Of course, they should be meaningful. So when we name something, it should not, remember, we want to kind of get away from naming everything X or Y or A or B, because those names may not mean much when we look back at the code. So even though those are valid names from an identifier perspective, we want to be really meaningful when we name something. We name a variable, name a function, name an object. Um, Here's one catch. The name cannot start with a number. So I can't name something just the number 0 or the number 1, because I can't start with that. Now, it can include that. So if I need to include a number in the name, as long as it doesn't start with it, that's okay. But names cannot start with a digit. That's just one rule of Python. Anything that you're assigning a name to, like a variable, function, whatever, cannot start with a number or else it will be invalid. Okay. So I'll show us examples of that later. Yes, they can start with underscores. Yes, that's okay. It can start with underscores. Of course, it can be lower uppercase. It can start with. It cannot start with a digit. It can have digits. They just can't be the first character of the name. Yes. Now, special symbols cannot be used in the name. So you cannot have a percentage, dollar sign, exclamation point, hyphen, pound symbol, at, ampersand symbol, at symbol. None of those can be used in the name. So those symbols are not recognized. So if you try to include those in the name of something, that will produce an error. So we don't want to do that. The other thing we want to avoid is naming something in the same name as something that already exists internal to Python. So those things are called keywords. So there are certain keywords that have a meaning in Python. They are built into the language. We cannot reuse those. They're basically reserved. So something like class is reserved because it means something. It means you're declaring a class. We'll talk about what that means later. Or something like global cannot be used because it declares something as global. Um, so, we'll learn what some of those keywords are. There's a list of them that are in the Python documentation, but we want to avoid naming things after built-in uh, functions or built-in keywords. So in fact, we've already used one, which is the print function. When we printed out hello world, we would want to avoid naming something print because print means something. It exists as a function. We don't want to name something print, right? that would produce it, because it would produce confusion. The interpreter would see that and say, "Oh, do you mean the function print, or are you trying to name something print?" It wouldn't know. So we want to avoid naming something that already exists inside of Python, like print or like class, global. There's many others. Okay. Lastly, and this one always throws people off, is that when we name something that is case sensitive. So if you name something lowercase a, that is a completely different variable or completely different function than if we were to name something capital A. These are different. They're treated differently. So Python will think that those are two different objects or variables or whatever the case is. So be really careful with case sensitivity. Python is case sensitive. Lowercase a will not be treated the same as capital A and whenever you're naming something. So if I have a variable and I set lowercase a equal to 5, and then I set capital A equals to 10, then if I print A, that would produce 5. But if I print capital A, that will produce 10. It's not the same. So it is case sensitive. These would be two different names, lowercase a and capital A. Okay. So we're going to do examples with these, but these are just some rules we have to abide by in the syntax. If we're naming anything, like naming our variables, naming our functions, naming our objects as we go along in the course, right? We just cannot, the main one that trips people up is we can't start with a digit, and we can't use words that already exist, like print. Oh, is my video stuck for people? Was it stuck? Oh, okay. Always let me know, because it might be. Always let me know, because it definitely could be. So it's better to know than not to know. Okay. Oh, no worries. Like I said, always feel free to let us know, because it would, if it is, then it's good to call it out. So no worries about that. Any questions about these names? Does it make sense about like how we name things matters, and there's just are certain rules that we have to follow. We want to avoid these wacky symbols. Um, we want to avoid naming things that already exist. We want to avoid starting with a digit. Otherwise, it's going to be a pretty standard like lowercase, uppercase mixture, maybe occasionally with an underscore mixed in there, or digits even. As long as we don't start with one, that's okay. Yeah, Tim, that's a good reference. The PEP. So PEP are the set of guidelines that the Python Foundation has kind of agreed upon as here's what you should use as your style guide. Here's what the community believes is the best style for Python. Those are good to read. Yeah, those are good references for really like formatting and styling your Python code to be in line with kind of what the community expects. Okay. Okay, so let me give you some examples. So the ones on the left are going to be valid. So we can name something my class, we can name something var underscore one. That's okay. Count. That's okay. Uh, but if we have like on the right, if we have something that starts with a digit, that would be bad. So this one is no good because it starts with this number. That's not good. This name has this wacky at symbol in it. That's no good. So this would be a bad name for something that would produce an error. Remember, the interpreter is going to see that and reject it essentially and say, you can't name something this, it's not valid. Same thing with trying to name something global. This is a keyword that already exists in the language. The interpreter is going to see that and get confused. It's not going to know if you're talking about the keyword that's built in or you're trying to come up with your own name. It's not going to know, so it's just going to throw an error. So again, we want to keep things simple. We want to use underscores where it makes sense. We don't want to start with numbers. We can use a mixture of lowercase and uppercase. That's fine. This is a good variable name rather than if I just called something X. That again, we're trying to avoid. That's something I always see in the beginning. I think is okay in the beginning, but it's something we really want to be conscious of is naming our variables very meaningfully. Like count is going to be more meaningful if we're keeping track of a count of something. We would rather call that count than if I just called it X. Because if you read the code, which do you guys believe like when you see it, you kind of know exactly what it means, X or count? What do we think? Which one like has more meaning to it when you see it? You know exactly what it's keeping track of, X or count? Yeah, count. I would agree with that. Count. Yep. So it's just like that's just a single example of trying to keep track of things in a meaningful way. That's a good name to give to a variable that would be keeping track of something, the count of something, rather than if we just called it X or Y or A or B. All right. I want to talk to you guys about indentation next. So now we know we have to name things appropriately, and the interpreter will give us an error if we don't name things appropriately. What about indentation? So indentation is a way for Python to understand what code gets executed together. Okay. So, and it also indicates that I am breaking the flow of the code from one section to the next. So the indentation is really important to signify to the interpreter there is a new section of code that has to be considered before I move on. So you should always use indentation whenever you have a colon, like we see a colon here with if else statements. Now we haven't learned about if else statements, but we will. But notice how we have the colon there, and the interpreter would be okay with this. This would work, okay? Which is a simple statement of saying, is 5 greater than 2? Yes. So in the case that it is, let's run this code. But we're only able to run it because the interpreter recognizes it's indented. So the indentation is really, really critical as it makes the interpreter understand what should be next. The interpreter understands what should be next after this statement, like an if statement or a loop statement. We will always have indentation. So this would actually throw an error because this is not indented. This is at the same level. And if you have Colab open, you could try this for yourself. If you had Colab open, you could try it for yourself. Is like this would throw an error where it says, I am expecting indentation, but you did not have any. Does it matter how many spaces? Yes, you want to use 4 spaces. This should be 4 spaces here. Spaces are tabs. Uh, I'm only laughing because it's a kind of a controversial question in the community. Some people get really upset over one or the other. I'm not one of those people. I don't really care. So most code editors set the tab automatically as 4 spaces. So a tab will do the same thing as if you manually just did 4 spaces. It doesn't really matter in that case. So either way, yeah, so the IDEs will do that for you. The IDEs will generally do that for you because they know it should go on the same line. Would it work as on the same line? Yes. In some cases it will, but not all. It depends on how complex it is. But what do you think is easier to read from a readability perspective? Which is easier? If it's all in one line, or is it more readable and easier to follow if it's indented? Yeah, that's the purpose. So yes, I agree. Indented makes it easier to read. So that's another reason Python really enforces indentation is to make it easier to read. There's a reason they do that. It's to make it easier to read. Okay. And that's one of the best selling points of Python is how easy it is to read and work with. The indentation really helps. So to summarize this, we are going to have to use indentation anytime we have uh, a statement with a colon. Anytime we have a statement with a colon, we're going to have an indentation immediately follow it. And there are certain statements that have a colon like if, else if, and any looping statement. Now, all of these things we're going to learn about. We'll learn about it in our next lesson. But anytime we have a colon, this is signaling the interpreter, okay, there needs to be a block of code following that, which is, yeah, as you say, Ramiro, it's like a hierarchy. Yes, that's a great way of thinking about it. It's saying, okay, I should check this, then do this if that's true. That tells the interpreter this is only going to be executed in the event that this is actually true. Otherwise, I'm going to keep going. Okay. All right. Any questions about the indentation? This is something we're going to learn about more as we go along. When do we use indentation and when do we not? We're going to learn about it when we get into the if else and loops, which we will study. But let me ask you guys this. Do we understand the idea or the intent behind indentation? Do we roughly get that idea? We don't know yet when to use it. I get that, but more the intent or the purpose of using it is to really like section things off. Yeah. Okay. Good, 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 good. Glad to hear that. Okay. Okay. Let's wrap up today by talking about comments. So, what are comments? These are like annotations or notes to yourself that are completely ignored by the interpreter. So when your code gets executed, the comment does not play any role in what gets executed. The interpreter will actually just completely ignore it the moment it sees the comment. It will just ignore it and go to the next line. So the purpose of it is for humans to leave a note to other humans reading the code. And that is very powerful, is to be able to read those, to leave those notes and not have it affect the actual code that's actually executed. So there's multiple ways to make comments inside of Python. The most basic is to use the pound symbol. So remember, we cannot use pound symbols to name anything. This is why, because the pound symbol is reserved for making comments. So you when you have a pound symbol like this, that immediately signals to the interpreter everything else that follows that on this line is a comment. Any other text that follows that on that line is a comment. And usually your editor, like VS Code, Jupyter, Colab, will color that differently. Maybe like a like you can see in here, this is a Jupyter example. You can see it's kind of a light gray, greenish gray, to signal that this is a comment. Um, Now you may be asking, why would we have comments? Again, you are going to look back at code weeks later, especially in this program. You're going to look at code and review and be like, what was I doing there? If you leave a comment, you'll remember what you were doing there, why you had that line. And not only that, like when you share your code with others, which in the real world you would be doing, collaborating with others, right? Adding in those comments can be really beneficial to do. So you will see me throughout the program. I'm going to leave a lot of comments on our demos and our notebooks that we work on together in the live sessions. I will leave comments mainly to call out certain things. Like I will say, this is a really important step, or we are doing this because. So I will leave a lot of comments, and I encourage you guys to do the same in your own code. Remember, they're free. They get ignored by the interpreter. They don't affect anything. They are notes to yourself. So use them accordingly. And there's actually multiple ways to leave comments, but I'll show us those as we go along. But this is the most basic, is you type in a pound symbol, and then everything else that follows that is your comment. Okay. All right, guys, that's it for today. What a great first session. Thank you guys. Thank you guys for being patient, going through the setup of some of those tools. I hope you landed on one that worked for you. Use that one going forward, please. If it's Colab, use that. Jupyter, use that. VS Code, use that. Whatever you feel most comfortable with, please use that. We have a lot to cover still. We're gonna continue on Wednesday. We will continue talking about Python. We're just getting our feet wet a little bit on Python. A lot more to cover. We're gonna get into the more nitty gritty of the code, so it'll be really fun. We'll cover if else, loops, how to control the flow of our program. We will do that. This is where we left off, was writing comments in Python code, which I did want to remind us of how to do that. It is going to be using the pound symbol to initiate a comment, and basically the Python interpreter will ignore everything else on that line. It treats all of that text as a comment. And again, like, comments are free. You might as well use them to your advantage to kind of leave a note to yourself of, hey, this is what this code is doing, so that when you come back and read it, you can understand it better. And so I encourage you guys, like when we do demos, and we will do a lot of demos, especially today, leave comments, put comments in there so you can make a note to yourself what this code is doing. So you will I think it'll be good to get in the habit of leaving comments to kind of mark up the code, to kind of remind yourself, oh, this is what it was doing when you look back at it in the future. Okay, so we had ended with that. What I wanted to do is move on into the next slide. So talk about basically how we display output to the screen, which we've already seen an example of when we did the hello world, which is the print function on the right. So this is by the way, this is a Python function, and it's a function because of these parentheses. So these parentheses signal that this is a function because it expects some sort of input to go inside of those parentheses. And the input that would go inside of there is going to be text, like some sort of text that belongs inside of quotes. And whatever we put there will display on the screen. So that's useful for us to like display information. We would say we are printing out information to the screen. So if we want to know the value of a variable or the value of something that we are doing a calculation with, or sanity check something in our code, we can print it out, which would be using the print function, and it will display that value onto the screen. So we will use the print function quite a bit. We haven't learned what functions are, but functions in Python are, designed to be chunks of code that execute and do something, and they take arguments, and it takes an argument because of the parentheses. That is signaling that there should be something inside of this parentheses here, which is going to be text. So whatever text you want to display, or maybe some variable you want to display, that would go inside of there. So we'll get the hang of using the print function as we go along, but just wanted to call out that's the primary methodology of kind of displaying something on the screen if we want to. Print function. Now, the reverse of that is asking a user to input some data. So that would be this input function. And this is something that, as you can see an example below, is we can put some text inside of this parentheses. So again, a function has those parentheses that signals it's a function. And we can put some text in there, which would be kind of what displays to the user as kind of a prompt, like here, enter your name, and that would display on the screen. And then there would be a box next to it. I'm going to show us this. I'm going to actually run this inside of a notebook in a minute. But then there would be a box that displays that would say, hey, enter your name, and then you can type input in, and then when you hit enter, it will save that input into this variable called name. So and remember, name, this is a valid identifier because it starts with a lowercase n, which is fine, and it has all valid characters. It doesn't have any wacky, pound symbol or at or anything crazy. So it's a decent identifier. So name would be okay. And so input is whenever you want to allow the user to input something, like it'll bring up a text box and they can enter some data, and that will be saved in this whatever variable you name this, you set equal to input. And then you can see, like, as soon as we put that in, we immediately we can display it. So we print hello and then comma name, which references whatever we stored, whatever the user input there. So I'm going to show us an example of that. But input is is our primary way of getting input from the user in a text box, so we can use that data in our program. Print is our primary way of displaying data that we already have in our code. We can print it, which will display it. So we're going to see many examples of these as along, but just wanted to call out those two. These functions, by the way, are built into Python. So we don't need to create them ourselves. They already exist. They're already built into Python. Nothing special we need to do to use them. We can just use them right out of the box. So again, we'll see this in our code examples that we're going to do in a minute. Where exactly would an end user be? So maybe we ask them for some input, and then we do so we ask them for some, like, their name, their email, their date of birth, those kind of things we can ask in the input, and then maybe we store them in a database, or we do something with it in the Python code. So whenever you want to accept input from an end user, that's when you would use this input. It just depends on the application, right? And on the application, like what kind of input data you want to accept from the user. Okay, so I'm going to show us this. Before we do that demo, let me ask you guys, which of the following, do we remember from Monday, which of the following identifier names follows Python's rules and best practices for readability? So not only, so you should be looking for the answer choice here that follows the rules, but also is a meaningful name. A lot of different choices. Okay. By the way, I'll come back to the answer to the original question, but let me ask this alternative question. Which one of these is not valid? Meaning Python would throw an error had to use it. Which one of these is not valid in general? Cool, great. It is C. You guys were right on top of that. Very good. So C is not valid. Names of things cannot start with a number. So that's C is completely invalid in general, and that would produce an error. Right, starts with a number, exactly, which we cannot do. Now, starting with an underscore is okay. That's allowed, so that's not an issue. And having a number be second after the underscore is okay as well. So technically, A and B would follow the rules. So those definitely follow the rules. Now, are they readable and meaningful is the question. I would argue that possibly not. var123 is pretty generic. I would argue that even though it's valid, like Python would not have any errors with that variable name, it's not very meaningful. It's too generic. It's almost as if we just called something X. We just call something var123. That's probably not going to be meaningful to us, and we're not going to understand what that really represents. If somebody were to come along and read it and see var123, that's probably not that great of a name. It's not telling us exactly what that represents. So I would say A is likely not a good choice. And C we know is invalid. So really, I think the only two options you could argue are B and D. I think D is a really good answer. It follows the rules. Underscores are fine. Everything is lowercase. That's fine. So it's valid, but it also is meaningful as a name, right? So final result value. We should probably like in our code, we would have context. We would know what that means. Okay, this is our final result. So that's a pretty good name for something. Um, this one is okay. It's just not that readable. 321 customer details, DB table. It's okay. I don't think it's not the worst. It definitely would work, but it's kind of a clunky name. I'm sure we could come up with something better, but it would work technically. There'd be no issues with it. Okay. So I think D is probably the best choice, but B is valid too. I think B could work for this. D and B I think are okay. Okay, good, good. You guys were right on top of that. I think you have a good feel for what the allowed names for things are, which is good. Okay. Um, I'm going to then swap over to this demo. So you guys should have the demos, and we kind of went through some of those first few last time to get you set up on Colab and Jupyter and VS Code. I am going to be using Colab for most of these, but feel free to use whatever you want to use. If you want to use Jupyter, if you want to use VS Code and run your notebooks on your own machine, feel free to use whatever you want to use. I'm going to be using Colab just for the simplicity of it. So this demo will walk us through opening up a new Colab notebook and then running those input and print. So some examples with input and print. So we'll do that together. Let me go over to that demo. So if you're following along, we are going to be doing demo 4. So it should be lesson 1, demo 4. Do you guys have this? Give you a moment to pull that up. Lesson 1, demo 4. You guys have access to this one? So we did 1, 2, and 3 on Monday, which were just getting those environments set up. So this is demo 4, which again, I know step 1 says open Colab. feel free to open your own notebook in VS Code or open your own notebook in Jupyter as well, whatever you're most comfortable with. I'm going to be using the Colab to do this, but feel free to use whatever works. We really just need a notebook to be able to run this code. So however you're running notebooks, whether that's in VS Code or Jupyter or Colab, any of those, either one is perfectly fine. So step one is to open up a notebook. I'm going to do it in Colab, which is what this says. And then you can make a new notebook and then rename it to my first program. I'm going to do that in a second. And then, so I'm going to walk through this live with you, but just showing you some of the steps we're going to do. The first thing we're going to do is just practice doing the print hello world again so that we can execute a print statement. So we'll practice that. We're going to make a second cell, which we can do in Colab or VS Code or Jupyter by hitting the plus button. There's usually a plus, you can see it here in multiple places. In Colab, you can do it right below an existing cell, or there's always a plus code here, which is kind of what you have in Jupyter. Usually in Jupyter, you have a plus button. So you can just hit that plus button, and it'll make a new cell. And so we'll make a new cell so we can write some more code. And then in this new one, we are going to practice doing some comments. We're going to practice doing some comments and then see how we can do some more print statements. Okay. So let's do that. Let me jump over to Colab. Let's walk through these first few steps together. And then we'll come back to this and finish out the rest of the steps because we're also going to do input. So I'm going to show you how to do these input, which you can see here, like the input is going to create a text box where you can put input and you hit enter, it will save it for you. So input allows you to get input from the keyboard and save that into a variable to use for later. Okay. So let's jump over to, I'll show us in a second. How do you rename it? I'll show you. Let me jump over to Colab. Okay. So I am over lesson 1, demo 4. Yep, that's the one we're doing. Okay, so I am in Colab. I'm going to start a new notebook. Start a new notebook in Colab. So now I'm here. I'm just on a fresh notebook. Nothing that interesting going on. Here's how you rename it. Just go up to this box on the left and almost like a Google Doc, just click into that name and then start typing to erase it. So see how I'm like hovering over that name and then I'm clicking on it and then I can start typing to erase it. So we can name this my first program and then hit enter and it will save that. Oh yeah. So if you're in VS Code, to rename it, do file and then save as, and then you can give a new name to it. File, save as. Okay. That's how you can rename it in VS Code. All right. Let's do the first step. Let's do print. So we're going to do print. So type in print and we can do parentheses. Remember, this is a function, so we need the parentheses to signal that we want to put some text inside of this print function. And then you want to do quotes. So you want to do quotes, the double quotes there, in order to allow us to put in some text. So Python will interpret what's inside of the quotes as text, and it will display that text. So we can do hello world, my first Python program. Okay, and then we can run it. So feel free to put whatever text in here. It doesn't really matter exactly what it is, but you put some text in there between the parentheses and then hit run. And the notebook will take a second to connect, and then there it is, right? So then you see the text displayed on the screen. Try that out. Are you guys able to run the print in your Jupyter, whether it's Colab, whether it's Jupyter Notebook, whether it's VS Code? Can you run the print? Install, yeah, install the in VS Code. Yep, try installing that. Okay, great. You guys were able to run that. Very good, very good. Okay. No, you don't want to save it as a JSON file. You want to save it as a .ipynb, just like this. See how this one is ipynb? That's the format you want. Remember, that is interactive Python notebook. You want that file, ipynb. Perfect. Yeah, you got it to run. You don't have any extension? No, if you're in VS Code, remember from Monday, you need to install the Jupyter extension. If you're in VS Code, you got to install the Jupyter extension. You have to manually save it. You can save it as a .py. I would do ipynb so you can open it in Colab. Type it yourself. Type overwrite what's there and type in my notebook, whatever the name is. Type it out yourself if you can. Like save as and then type out the full file name yourself. Now let's practice a comment. Let's practice a comment. So let's do a new code cell. So we made it, you can either do it here. If you hover over your cell, you can hit plus to build a new code cell, or you can hit plus here to make a new code cell. So let's do that. You should be saving, don't worry about the type, just type in the name .ipynb. I don't think you need to. Or you could just hit, what you could do is you could just hit save, and then in your file explorer, you could just rename it. So if you just save, it will save it to the default location and then just rename it. So maybe try that route. Just do save. Just save it, and then it should try to save it as an ipynb. Okay. Okay, let's practice. So the next step in the demo, if you're following along in the demo document, it wants us to do, so we did the print. We want to do a practice some comments. Okay, perfect. Let's practice some comments. So remember I told you that we can do comments with the pound symbol. So this is a comment. So practice writing a comment. Remember, you start a comment with a pound symbol. It will get ignored by the interpreter. So feel free to type in whatever text you want. I'm just reminding us that whatever the comment is going to be ignored, and we can have whatever code below that we want to have, and that comment will get completely ignored. So let's do another print. So write a comment, hit enter, immediately below that in a new line, let's do another print. this code gets executed. So we know this print statement is going to get executed, but this comment is going to be ignored by the interpreter. So let's run that. So this code gets executed, this comment gets completely ignored, right? That comment gets completely ignored, which is great. Try writing a comment. Are you guys able to write comments? So write a comment and then try writing a print statement right after it. And feel free to put whatever text you want inside the comment, and feel free to for the comment, is the space after the pound symbol required? No, it's not. So we could test that out. So I removed the space. Doesn't matter. It's just for readability. I usually like doing that so that I have some space after it. And this is it's just a little bit more readable, right? It's not mixed together. It's just for readability. Great, you guys wrote a comment. Okay, perfect, perfect. We're able to write comments. Really great. Okay, okay. If you put multiple code lines, do we need any separator? Like, no, they just go on new lines. So do you mean like a second print statement? We could try that. Let's do a secondary print statement. So we can do print. This one is on the next line. No separator needed. Do you see that? See how it's on its own? I did a print right below this other print, and as long as they're on their own line, that's okay. They just need to be on their own lines. They don't need any separator. If we run this, then this one gets then see how this is now printed out below it right there. Is there any character limit on the comments? No, there's no character limit. But there's no character limit, but a good practice is to not, like, you don't want this to be super long and to take up the whole screen, right? Because then it's not really readable. So there's no limit, but you don't want to have overly long comments. You want to keep them kind of concise and short. So just so you can read them and they don't take up a lot of space. Not able to add print statement below. Why is that? You should be able to. Should be able to have a print right below this print. Shouldn't be anything that. Make sure you close this parentheses. Make sure every print needs to close the parentheses. And you also need to close the quotes. So close this quote within the print. That needs to be done. So you should be able to run, I'll paste this for you guys in the chat. You should be able to run this. All right. One thing I want to show you guys is just like the demo says in the Word document, you can do multi-line comments. So if you need to do a lot of comments, all you need to do is triple quotes. So triple quote, then triple quote, and then everything in between. It's interesting that it did that. Yeah, so we can do pound symbol, pound symbol, pound symbol, pound symbol, and that should all work. So we can do that. Yeah, I think it's a Colab thing, but normally in like Jupyter or in Python, it will work just fine. But like in Colab, I think they don't like the triple quotes. But yeah, do you guys see how I just did it like this with the pound symbols? That's okay too. Everything between these uh pound symbols is a comment and is ignored. So now we should be able to run that. So there we go. Everything gets ignored there. Does that make sense to us? The pound symbol comments. Does the using the pound symbols. So notice how we use that to do multiple lines of comments. So we did one here, we did one here. We can have we can have as many comment lines as we want, and they will all get ignored. What is those? It's supposed to be multi-line comments, but for some reason it's not working. So the triple quote is supposed to be like representing that you can have a whole block of comments. I don't know why it's not working in Colab for me. It's working for you? Okay, I don't know why it's not working. Single quote? It still displays here, which I don't get why that's happening. It's kind of weird to me. Yeah, I don't get why inconsistency. It usually works for me. I don't get that at all. Still doesn't work for me. I don't know why that doesn't. Yeah, I don't get why that's not really liking those triple quotes. Oh well. I mean, not a big deal. We can just do okay, we can try a single. Still doesn't work. Yeah. Oh well, we can do a pound symbol. That will always work. Pound symbol is honestly more popular anyway. Most code that you see in the wild will have pound symbols wherever they're doing comments. So that it's fine just to use a pound symbol for now. Yeah, that's correct. I don't know why. That's correct. I don't know why Colab doesn't seem to like that. It should be ignored generally with the triple quotes, but that's okay. I'm not too concerned about it for now. I guess and when I do comments, you're usually going to see me using a pound symbol anyways. It'd be very rare that I would need to do quotes. Yeah, it's weird at Colab. It doesn't work very consistently. That's okay. All right. What I want to show us is I want to move on to the input. So I want you guys to see, I want you guys to type in this code here that will take input from a text box and save it into a variable called name. So the code we're going to do is going to be like this. It's going to be name equals input, and then we'll put please enter your name. Okay. So this, by the way, I'm going to comment this code here. This code should create a text box for us to put in our name. Okay, so that's what should happen. So when we run this, it should open a text box right below this, and we can type in our name and hit enter. And when we do that, it will store that result in this variable called name, which we can use wherever we want to in the code. So if I hit run, there's that text box. Do you guys see that? There's the text box, and see how it says, please enter your name. And so we can type in our name and we hit enter, and there it's stored in the name. We can even display name by doing print and then the name, which will display the name that we stored when we did the input. So try this one out. Try this code out for yourself. Try typing input, parentheses, and then you want to have some text there. It doesn't matter exactly what it is, but something like, please enter your name or enter your name. Try that out, and then it should store, you should be able to type in the box that shows up, hit enter on your keyboard. It should save that, and then you can print it out. You can print out that name, which will display that whatever we typed in before. What does it look like, Roberto? What does it look like? Were other people able to run this? Oh yeah, thank you, Melanie. Yeah, I see that. Perfect. Perfect. That looks good to me. You don't need a space. It just looks nice, right? It's so that's a good practice to have the space so that this code is evenly spaced out and it looks nicer on the screen. Um, Name equals input, print hello there, name. You need, yeah, so Roberto, you need a comma after the quotes. After the quotes. You need a comma after the quotes to signal to Python that you're putting in, you have some text and then an additional input. So it needs to be more like, it needs to be like this. Print hello there, and then you need an extra comma. See how I have an extra comma after the quote? You need that. Sorry, now Roberto's Chiati. Hopefully I'm pronouncing that right. Okay, so do we feel good about input and what it does? Perfect. Do we feel good about input and what it does? It brings up a text box. It did you hit enter, Roberto? To like, were you able to type something in and hit? It's gonna run until you hit enter. You have to type in the text and then hit enter into the box. So let me rerun this. So see how it's still running? See how this like it's gonna keep running forever until I type something in. And then when I hit enter, it will stop. What does your code look like? Okay, that looks right. Try stopping it and rerunning it. Try hitting the stop button and then rerun it. You should so yeah, you should put that in a different cell. So if you separate your code into individual cells, so you could do like you could do name. So we could separate this. So this code is the only code that's running in this cell. That doesn't make sense, Joffrey. Something else is that doesn't make sense because like this Colab tab is only taking up 235 megabytes. So something is chewing up your memory. That's not really, I can't imagine. Are you using Colab? You can see like it's not using that much, only 240, 230-ish. Yeah, I don't think Colab is the culprit unless you loaded in some really massive data or something. I can't imagine that's the issue. You did, you loaded in data that's I mean, yeah, then it's gonna it's gonna take in memory. Oh, okay, okay, okay. MJ, what are you on? Are you on? Yeah, could you screenshot it? If it's not working for you, could you try Colab? If you could you try Colab just for the sake of like getting it running? Things should work in Colab pretty easily. You're using Colab and nothing's working. Are you making sure it's a code cell and not a text cell? It's not a text cell like this, which would be like blue. This is where it will be blue. Do you have that? You need to make sure it's code. Yeah. And when I run that, it's gonna display text. Yeah. Okay, great. Glad that it's working. Great. Okay. All right, one more example. What I want to show you guys is how to include the name in a print statement. So if we do something like print, so we can include the name in a print statement. So if we do something like print, and then we have hello there, and then we have this, and then we have welcome to Python. Um, this will uh, this will display all of that together. So notice that we can have as many pieces of information that we want to display kind of one after the other, as long as they're separated by these commas. So we have this text, comma, this text, because text is stored in that variable, um, then this text, and then we print that all out and we can have this whole collection of text displayed to the screen. Try that one out. Oh, they do the same thing. They do the same thing. So the comma and the, sorry, yeah, I just noticed the demo does a plus. They do the same thing in Python. So we can swap that over to a plus. Both of them work. They have the same, I shouldn't say they do the same thing, but they have the same effect. They have the same effect. Actually, there's no, you need a little bit more spacing here. So the comma gives you a little bit better spacing. So let me break this down. So plus adds together uh, text. And so what we're doing here technically is adding all our text together and then displaying it. So plus adds together text, and then the comma um, prints out multiple pieces of text. So they have the same effect. Oh yeah, you can use either one. Okay. One thing I wanted to show you guys too, by the way, in Colab, if you're working inside of Colab, I want you to hover over your name variable. So if you just take your mouse and hover over that, do you guys see what it says here? Do you see how it says string name and then it has the value of that, which is my name. So that's something cool about Colab is if you hover over variables, it will tell you what their type is. Now we haven't learned about types, but any text inside of quotes is a string. It's what we would call a string. We're going to learn about that. And um, it also displays what data we currently have stored in that variable. So all you have to do is hover over a variable to see what the value is. Yeah, that's kind of a limitation of VS Code. That's true. It doesn't show you immediately on hovering. Don't see the value on hovering. So click into the cell. You have to click into the cell and then hover over it. Click into the cell and then hover over it. It should work. Yeah, you have to click on the cell or whatever cell you're on and then hover over that and it should work. Mariel asks, how do we integrate that Python code to a client application for a user to enter a value? Um, we would likely have a different set of code to do that. There is Python code that can get a UI, and we will see that later on in the like way later on towards the end of the program. We'll see that we can write Python code to do a UI essentially to make like a almost like a web page for someone to enter some input. We'll see that much later on. So we're not going to get to that right now. It's really complex. What is the purpose of having multiple cells? It's so that we can run individual pieces of code within those cells. It allows us to isolate, right? Because I can run code inside of these cells and they don't affect any other cell. So it's just for like debugging and isolation, which is nice, right? I don't need to worry about running all of it at once. I can run one cell at a time. Okay, any other questions? Um, can we execute multiple lines together? Yes, we did that here. I had multiple, so I'll show you again. I can do print. This is one statement, and then I can come down and do print. This is another, and then maybe I can do some math. So you can have as many lines as you want within a cell. Within a cell, you can have as many lines of code as you want. Is there a way to tell it the order the cells execute? You know, if you go up to run all, it's going to run them all in order from top to bottom. In order to tell which cells to execute, you can rearrange them. You can always like, so I could rearrange these cells, by the way, I think there's a way to move it down. So I can move it down. So now I'm rearranging. So you can move cells. I think you can even drag and drop them. So notice how I took the one that's at the very top and I'm moving it down. Otherwise, you have to click, right? You just have to like I can run them in any order if I just click. Like if I click here, it will run that one first. If I go back up here, it will run that one next. So you just click around which ones you want to run. Does that make sense? I can run them in any order as long as I click on whatever order I want to do it in. Okay. All right. Perfect. So that wraps up that demo. I hope it was informative. I hope you saw the print statement. We're going to see that many times. The input statement. That's pretty cool. And you got to run some Python. So if it's your first time ever doing programming, congratulations. You ran some Python code. That is really exciting. So glad we got to do that. Um, let's go back to our notes, and then we'll let me share the screen. Okay. So the next thing on our agenda is to cover variables and data types. So I just said like text is the string data type, but let's learn about all the different data types that are going to be available to us inside of Python, and let's talk about variables. It's going to be a good discussion. So I think what we'll do is we'll take a 5-minute break now, and we come back and we can start this discussion about variables and data types. So let's take a 5-minute break. And so let's try to be back around 8:30. Okay. Try to be back around 8:30. Okay, so what are variables? These are basically our way of storing data to make it easier to reference them and manipulate throughout our program. So we've actually already used a variable. We used one in our demo we just did where we called the input the name. We stored that input into a variable called name. And so variables just really are a reference to some data. That's all they are. They allow us to reference that data throughout the program. We can store information into a variable and then access it throughout our code. So on this screen are some examples of variables. Now, variables have names, which is why I said usually we want those to be meaningful. Like X is a valid name, but it's not that interesting of a name. It doesn't give us that much information about what it really means. So probably not the best name. Um, but we have things like we can store some text inside of this variable called name. We can store a number inside of this variable called price. We can store a true or a false value inside of this variable called is underscore active. And so variables will show up all over our code, and they are basically our way to reference some values. Now, these things over here are basically different types of data that we need to learn about, right? So we need to learn about what is a 10 versus what is in something inside of quotes, which is a string, versus something that has decimals, which is a floating point number, versus something that is true or false, which is a Boolean value. We need to learn about those data types, but notice how all of these are being referenced by a variable that has some name to it. Okay, so the variable is this guy. It is our reference to that data, and we will use variables throughout so that we can have references to information in our code. So variables are fundamental to working with Python. Now, variables can store different kinds of data, so I just alluded to that. And so the different types of data available to us in Python kind of fall in these two different categories. One being single values, or what are known as scalar values. So these are things like integers, so the number 10, the number -1, the number 2,323. Those are all whole number integers. Floats, which are anything with a decimal. So 32.3, 3.14, -1.2, those are all floating point numbers. Booleans only have two options. They only have true or false. So they represent kind of a binary value. which we say is true or false. And then we also have complex numbers, which have imaginary parts to them. We won't really be dealing with complex numbers too much, so I wouldn't worry about them. But in reality, Python supports working with the complex numbers and doing complex math. But so complex numbers just have kind of a real part and an imaginary part to them. Wouldn't worry too much about that. Again, we're not really going to work with those ever throughout the program, but it does exist. Python supports it. So scalar data, single values, think numbers, think single numbers like floats, think integers, single true or false values. So these kinds of data can be stored into variables. On the opposite end of the spectrum are aggregated types that we are storing multiple things. So we're going to learn about all of those, but probably the most common and one that we've already dealt with is going to be a string. So a string is technically an aggregated type because it has multiple characters that form, an overall string, which is a string is usually, it's a string because it's inside of quotes, right? It's inside of these double quotes or single quotes. Um, Python actually doesn't care about quotes really in terms of if it's single or double, as long as you're consistent with it. Like if you start with double quotes, you should end with double quotes, or if you start with single, you should end with single. Python doesn't really care either way. Um, so strings are going to represent collections of characters. We are going to talk about sets, which are basically like an array of unique values. So we'll talk about sets. We'll talk about lists, which are a really important structure. It's basically an array that can hold many different types of data. So we'll talk about lists. We'll talk about tuples. So if you see that word tuple, that is some people pronounce it tuple. I like to call it tuple, but that is going to be very similar to an array. It's just going to have slight differences in if you can change it or not. Tuples you actually cannot change once you create it. Versus lists, you can modify lists. You can add things to it. You can remove things from it. Tuples you cannot. So we're going to learn about those differences as we go along and start working with these different types of data. But they are designed to hold multiple values, right? So you can see in that example, that list has integers, it has strings, it can hold multiple types, which is if you're coming from other languages, is generally not the case. Like arrays in Java, arrays in C, they can only hold one type of data in the array. They can't hold multiple. Um, then finally, a dictionary. A dictionary is if you're coming from other languages, it's like a map, a hash map. Basically, it allows you to have keys mapped to values. So dictionaries are highly useful for storing information where we want to reference like this value maps to this value. So for instance, in this dictionary, the string A maps to 1, and then the string B maps to 2 and whatever it maps to. And this will allow us to look up values in the dictionary. So we could look up, hey, what is the value stored at key A? Or what is the value stored at key B? Those kind of things. Dictionaries will be incredibly useful. We're going to explore all of those more as we go along in the lesson, but for right now, you should be making sense that there are some data types that store multiple values, like lists, dictionaries, strings. And then there are some data types that only have a single value, like a single number, like a float, integer, Boolean. Okay, so more to come on aggregated data. We're going to work with those, learn about the differences, learn about what it looks like in the code to work with the set, a dictionary, tuple, list. But those generally hold multiple values or can hold multiple values, whereas scalar data is only going to hold one. Okay. All right. So as we said earlier, integers, floats, booleans, they only hold a single value. By the way, inside of Python, if you ever want to see what the type of a variable is, so let's say we know we have a variable called name, we can always check the what data type it is by using the built-in type function. So we can use type and then pass in that variable, and this will display what data type it is. So if we stored the value 42 in some variable called int, if we did type, if we did type of this, it would produce int, which would say, okay, this value is an integer. Versus 3.14, that's going to be a float, versus capital T true, that's going to be the Boolean type bool. Okay, so we have integers, we have floats, we have Booleans, all of which we will use throughout, and we'll see where we will use those, one versus the other. We'll learn about that. As I said, complex. So just showing you here that those exist. Obviously, like I said, complex has a real part and an imaginary part, which you can access separately. So if you store a value as a complex, you can access its real and imaginary parts separately, which you may need to do for some type of calculations. Um, Again, we won't really work with complex numbers in this program, so not a big deal for us, but it is supported. And a lot of mathematical packages in Python will use complex numbers if they need to, but we won't really do it in this program. There's not really a need to for us. All right, so aggregated data. We have those strings, which we've already seen. Those are the things inside of quotes. We have sets, which are going to be collections of data that are unique, basically only allowing one copy of those elements inside the set. We're going to learn about that. List, which is going to be a collection of items which we can change. We can add things to it, we can remove. Lists are a really awesome structure in Python. What I want you to see right now, though, is you can start to see the syntax differences, right? So like a set, a set is where we have this brace. Notice that a set is created with a curly brace versus a list, which is created with a bracket. So right away, like when you see a brace, you should be thinking either a set or a dictionary. Those are the two things that are created with a curly brace. And it's a dictionary because a dictionary will have the colon, which will map. I'll show you that on the next screen, but that will map things from key to value, depending on if left and right of the colon. But do you guys see that, like the syntax difference of a list has a bracket, a set has a curly brace. That's just one small difference. We're going to learn like what is the actual difference between a set and a list, but that's just one I'm pointing out right now. What does mutable mean? So mutable means that we can change it. It's able to be changed. So immutable would be we cannot change it. Yeah, and one thing about a list that's really nice is every list has a natural ordering to it, which is actually really beneficial. So a list has a notion of the first item, the second item, the third item, the fourth. That's really important for accessing data within the list. Okay, so lists are really powerful. Um, Yeah, so a set, the reason it shows it's in a different order is because a set does not maintain order. A set never maintains order because a set is not, you do not access items by order. So that's just something unique to a set, is that it doesn't have a natural order. So every time you print it out, it will display in a different order, potentially. It's random. It's random order when you display it. A set is just meant to be a general collection. Think of it like a bucket. Like, here's this bucket of items that I have. It's just a collection of items. A list actually maintains an order, a consistent order of items. This is different. So we'll talk more about that when we get into those. All right, so I wanted to show you also the tuple in the dictionary. So a tuple is also a collection of items. Now the tuple is ordered, so it's like a list. It's ordered, but it is immutable, meaning you cannot change a tuple. So once you create a tuple, you cannot change it or else you'll get an error. Python will tell you, hey, this is immutable. I can't change this. So if you changing being if you try to add something to the tuple, if you try to modify one of the entries in the tuple, like if I go in and try to change this A to a D, this would not be allowed. This would throw an error. The interpreter would say, hey, you're trying to change something that cannot be changed. So tuples are immutable, but they have a benefit beyond a set of actually being ordered. So there's a natural ordering to a tuple where this is the first item, this is the second item, this is the third, and every time you display a tuple, it will be in a consistent order. But tuples are not like a list. You can't change it. So tuples are useful for situations where you want ordering, but you don't want anybody to change any of that data that's in the tuple. It's not changeable. Mutable meaning it just means changeable. Like you can modify it. If something is mutable, you can modify it. Immutable, like a tuple is immutable. We cannot modify it. Once we create it, that's what it is. Okay. Yeah. Okay. So then finally a dictionary. Now you By the way, look at the tuple, see how it's created with a parentheses. So that's different than the curly brace, that's different than the bracket, right? So a tuple, you know it's a tuple because of the parentheses, and the items are separated by a comma, just how they are in a set and just how they are in a list. Um, so the parentheses gives it away that it's a tuple. Now look at the dictionary, and the dictionary is a collection of key value pairs. So this is a key value pair, this is a key value pair, this is a key value pair, and on and on. We can have as many as we want. And one thing I want you to notice about this is there is no restriction on the data types of the keys and the values. So keys can be integers, keys can be strings, values can be integers, values can be strings, values could be floats. Values could even be other dictionaries or lists. So value, like we could have what's called a nested dictionary where we actually have something mapping over to another dictionary. That's totally possible in Python. So we can have dictionaries that part of the values inside of the dictionary actually have our dictionaries themselves. And that would represent kind of a nested structure there. So, for instance, this name could map to a dictionary with everybody's name in it, um, or it could map to a list. Um, you know, could map to a list. It could map to whatever. It could map to a tuple. So there's really no restriction in what the keys and values are going to be. Brent, is it more efficient than the other? Is what more efficient than the other methods? Just want to clarify your question, so I answer it properly. The tuple versus using an array. Yeah. So these are all good questions. So the tuple is guaranteed not to be changed. So it is a little faster when we are looking up items, like when we are referencing items, it's a little bit faster because we know that it's not going to be modified ever. So everything's going to be consistently in the same spot. So like whatever's first is going to stay first, whatever second is going to stay second, and on and on. So tuple is nice in that sense. A list can be changed. So whatever is first may not guarantee to be first in the future. We can modify it. We can remove things. We can add things to the list. So we can expand. The list is very like dynamic. So the list is less efficient because it's way more dynamic. Does that make sense? Like it can change. You can keep expanding the list by adding things to it. You can shrink the list by removing things from it. So list is way more dynamic, which for a lot of scenarios is useful. Right? We want to be able to add and remove and modify things. But a tuple is more rigid in the sense that once you create it, you cannot change anything about it. Yeah, yeah. So a dictionary is good for, yeah, like a phone book would be a good example of a dictionary because with a dictionary, you're usually looking up things. So like in a phone book, you have a name that maps to a phone number. Um, so yes, you have that a dictionary will map a key to a value, just like a name would be mapped to a phone number. So yeah, a phone book makes a lot of sense. Um, a list is like a normal like your grocery list. Like you may add things to it, you may remove things from it, you may change things on it. It's very dynamic. A tuple is kind of like a fixed set of data that's ordered in some way. So maybe like what you would see on a letter, like you have your name, you have your address, you have your zip code, like you kind of have those, and it should stay that way in order to mail the letter, kind of thing. Can you convert a tuple to a list? Yes, you can do vice versa. You can convert a tuple to a list, and you can convert a list to a tuple. Yes, you can convert between them. I'll show us examples of that later. Okay, so just to recap there, tuple is not changeable, but it has an order. So it has a natural ordering to it. Whatever is first, whatever second is second, third and third. So you can access things based on their position within the tuple. That's really nice. But you cannot modify anything about a tuple once you create it. Okay. A list has an ordering to it. You can access things based on their position, but a list is dynamic. It is mutable, meaning you can change it. You can change values, you can add things to it, you can remove things from it. Okay, so very dynamic. That's what a list is. Dictionary, it maps keys to values, no restrictions on what those keys and values can be. All right. And then a set. A set is, think of it like a bucket. It just has things in it. A set has no order to it. So you cannot access things based on their order. And every time you display the set, you can get a different ordering. Um, but a set only is special in that it only allows unique items. So if you try to put multiple copies of a piece of data, it's only going to keep one of them. So a set is like a bucket with only unique things in it. Okay. So, and sometimes that's really useful, is to know like what are the unique values. A set would help us maintain that. Any questions about those? We have to work with this and see this in the code, and we will. But just any questions right now about these different types of data that we're talking about? Okay, very good. All right, let's talk about assignment. So what that means is, oops, let's talk about assignment, which means that we will be taking a variable name and assigning data to it. Now we've already seen this. We already saw it in our demo where we did name equals input. So the equal symbol is how we assign values to a variable. That makes sense, right? It's very like self-explanatory. But what we should think about with a variable is really the fact that a variable is a reference to that data. Okay. So when we say x equals 34, we are assigning 34 to the name x. So x becomes a variable, which is referencing the data, which is an integer 34, right? What's really interesting about that, and this is how you can kind of test your intuition of the fact that this is a reference, is if we come along and have another name, y, and we set that equal to x, this is just saying that we are creating another reference that is equal to the reference we already have. Now, why would we ever do that? Probably we wouldn't. That's kind of redundant. But this just proves that they're ultimately references, because when we display X, we get 34. Of course, that's what we stored the value 34 referenced by X. And then when we print Y, we get the same number, right? We get 34. And why does that happen? Because we literally declared Y equal to X, meaning Y should reference the same data that X does. Okay. So as variables, they are equal, meaning that X is being assigned to Y, meaning Y should reference the same data that X does. So they contain the same data. Now, what's interesting is if you print out the ID, so the ID is the internal memory address of the reference. Now, usually we don't care about that, but this is just to prove the point, is that you can see these are the same address. These are the same. That's by design, because we're saying, okay, I have this reference X, which is referencing this data 34. It's stored at this address. And then when I come along and say, okay, Y equals X, that's just the same reference. You see how it's the same exact address, same reference. So just proving that variables are literally just references to data. They allow us to reference that data, which is really, really, nice. So we can reuse X throughout the code. We can reuse name. We can, whatever we create, we can reuse. If you look over to the right, we have an alternative example, which now resets Y to store a new value. So instead of saying Y equals to X, we actually overwrite Y and reassign it to the integer 78. That's a new piece of data, right? 78. So now if you look at their references, they're different. These are different, and that makes sense because now they're pointing to two different pieces of data. Right? X is pointing to 34, Y is referencing to 78. So of course they're going to be different addresses. And this is a bit of a typo. This should say ID of Y, because we're talking about Y. It's a bit of a typo there. Okay. So hopefully this example is just to reinforce the fact that when we use the equal sign, we're setting a variable name equal to a piece of data. Right? And that is creating a reference to that piece of data. That's all we're saying with this. So we are assigning a piece of data to that reference, X or Y or whatever it is. Okay. All right, let me ask you guys, what is the default data type of a variable assigned using the input function? This is an interesting question. We didn't actually cover this, so I'm really curious to see what you guys think about this. A lot of votes for string. Let's get a few more. Perfect. Yeah. So a lot of votes for C. It is a string. So that begs the question, like, what happens if we input a number? Like, what happens if we put in a 2? What happens to that? That 2 will actually be read in as the string 2. So if we use the input and it pulls up that text box and we put in a number like 2, and we set that equal to the variable X, whatever we name that, name X, whatever. What that really means is X is going to be equal to the X is going to be equal to the string 2. So that's something to be cautious about with the input, is it always assumes the input data is going to be a string. So luckily, there's a way to convert between strings and numbers. So if we wanted to turn this into the actual number, what we would do is use the data type function int, which would convert this would convert it over to the numerical 2. It would actually convert it from a string to an integer. We just use int. Or we could use, like, if somebody put in a decimal like 2.5, then we could do a float of 2.5, and that would convert that over to the number. Okay. Let me actually show you guys this. Let me go over to Colab real quick and show you guys this. I know it's not in a demo, but I think it'll be better if I just show you what I mean by this, because it's an important point with input. So let me stop sharing there. Let me go over to Colab for a second so I can show you literally what this means. So go back into the notebook here. So what I want to show you is that when we do input, the default type is string. So for instance, when I do value equals to input, and let's try enter your age. Oops, enter your age. And then we run this. So we enter the age. Now, this is going to be read in as a string. So even though I'm putting a number there, it's actually going to be read in as a string. So now, look at what the type of value is. It's a string. Do we see that? So this number, even though we put in a number, the input function always converts it to a string, no matter what we put there. If we put a decimal, if we put a large number, it's always going to assume it's a string. So luckily, we can convert to an integer by using int, the int function. So we can say value, or we can do int value, which will convert that 32 string, because right now, if I were to just display value, it's a string 32. You can see it inside of the quotes. But now when I do this and I can run that, now it's an integer. Do we see that? Now it's actually a number, which is great. It no longer has those quotes. It's actually going to be treated as an actual integer, which may be useful for calculations or storing it or whatever we need to do with it. So that's just one piece of caution with the input is if you're working with numerical data, it's going to treat it as a string. We have to convert it. Okay. Questions on that? Does that make sense to us? Like the input's always going to accept the input as a string. So if we want to work with it alternatively, we should convert it. You can, yeah, so like you could convert, if I did this, if I wrapped this around in the int function, that would automatically take whatever this returns would automatically be cast over to an int. So we could do that. So let me show you that. So when I run this, I can put in 32. And it's like automatically going to be casted to an integer. So now it's an integer. Does that make sense? Like when I wrap this int around the input, it's going to automatically convert. What did you put in the input box? So yes, you'll get an error if you don't put in a valid integer. So let's put in, like if I put in my name, this should be an error because I don't know how to convert this string over to a number. It doesn't make sense to do that, right? So this should be an error, right? That'll be an error because it's a string. So why did you get an error? Input, enter your age, value, int value. Did the text box show up? Maybe try separating it into a different cell. Try putting the other two lines in a different cell. You need the text box to show up, and then you need to enter something. Yeah. Okay. All right. Does this all make sense? Any questions about this? About the input function? Okay. Good. Okay. Let me go over back to the notes then. Okay. All right. So we have another demo. We'll do that now. I was just kind of doing one, but let's go back over to this will be demo 5. Let's do that. So we're going to practice assigning different values to variables and displaying them just so you get in the habit of being able to create your own variables and just go through that kind of one more time. We'll do this one relatively quickly and then move on. So this will be demo 5. So let me pull that one up for you guys. Okay, let me share my screen. All right. So this is going to be demo 5. Um, Now, again, like feel free to use whatever platform you've been using, Colab, Jupyter Notebook. I know this instruction says set up a Jupyter Notebook. Feel free to use whatever you want. You can use Colab, whatever's been working for you to build your notebooks. So obviously this looks a little different than Colab, but it's because it's the Jupyter. So we create a notebook. Now, what I want you to see is this takes the approach of everything we just did. Let me zoom in on this. I know that's a little small, but this is doing everything we just said we could do, where we essentially take, so I just want to zoom in on this. Notice that we take the input, and this will be saved as a string. So this will be saved as a string, and this will be saved into this name. And for instance, this will be saved as a string, but we convert it over to an int, which is exactly the kind of example I just did, right? Where we take an input, we convert it over to int. Does somebody have the demos available? Like if somebody doesn't mind sharing those in the chat. I don't have the PDFs. They should be from your LMS. They should be in the reference material. There should be a demos folder that you can download. If somebody has those and doesn't mind sharing them, they have that folder of them, like a zip folder of them, that'd be fantastic. Yeah, thanks. Thanks. This is the demo we're going through currently. Perfect. So for you guys having trouble navigating the demos, please download this zip folder. Download the zip folder that these guys are uploading. Thank you so much. Download the zip folder so you have all of them. Please take a moment to do that. Okay. Uh, Copied the code and got an error at height value, use foot, not meter. I mean, it shouldn't matter. You should just be, the point of that one is to put in a decimal. How to create a new file? What platform are you on? Colab? I don't know what platform you're on. Colab, just go to File, New Notebook in Drive, I think is what it's called. Do you see that? It should be like it should be at the top. There should be a file and then New Notebook. Let me go over to it. Uh, this one, you don't see this. File, it's at the top of the notebook. Do File and then New Notebook. You don't see New Notebook. If you don't see that, just go to a new tab. Just go to a new tab and go to Google Colab. You can always do that. Just start a new just go to Google Colab and then it will let you like launch a new notebook. So just do that. Just do a new tab if it doesn't work. Okay. So by the way, one of those examples was entering a float. So it looked kind of like this. So we had our height is equal to float, and then we had input, and then we had enter your height, and then this was uh, some sort of this should be some sort of decimal value. So let's say it is I don't know 5.7, whatever that is, feet. It doesn't. It's just some decimal. And then we hit enter. That will store the height as a float, so that when we display the height, it will be rendered as a float appropriately, right? That's what should happen. That's the point of that. So it just needs to be some decimal. It should work. All right, let me go back to the demo document. All right. Were you guys able to run some of these? Like, were you able to run some of the inputs and change them? So try these out on your own real quick. Like try doing int and then input for enter your age. It should convert that. You should be putting in a number or else you'll get an error. And it should convert that over. By the way, I wouldn't worry about this last one because we haven't learned about the comparison operator yet, which is this equals equals. So we'll learn about that in a little bit, in a few minutes. So don't worry about that one too much right now, but at least these first few should make some sense and we should be able to do. Were you guys able to run one of those and convert over the float or int and do the input and convert it? Did that work for you? Give it a try. Let me clear that. Any questions about that? Should look something like this. Good. We're good on that, on converting over the input. Okay, perfect. Sounds like we were able to run that and it was okay. What are you entering for the feet? Like, are you literally entering like quotes? Yeah, that's not going to work when you do that because it's going to there's a string F, there's a character there. It's not going to be able to convert over to. So if you did 6.4, that would work. Any decimal should work, but like the F is a character. So the float doesn't know how to convert over a character, right? Yeah, so that's not going to work. You need to put in a decimal to be able to convert over to the number. Okay. Very good, very good. Let's go back over to our notes so we can continue along. 1.7, yeah. If you have any character, it's not going to work. It's not going to work. You need to put in a decimal. All right. Let's talk about operators. So these are going to be really important. Let's talk about operators so that we can uh, be able to compare things and work with things. So let's talk about Python operators. So what are operators? What do we mean by that? In Python, operators are special symbols or keywords that perform operations. So as the name suggests, it's performing some level of operation, which means that the interpreter should do some sort of logical operation, mathematical operation, relational operation to produce a result. So usually that means there's going to be multiple variables that are going to be used to do some operation between. So an example of an operation would be like adding, subtracting, multiplying. That's an operation. But we can have logical operations like taking the logical and or logical or of things. We'll see what that means. But in Python, there's many situations where we want to be able to do operations between variables, whether that's simple mathematical or maybe some type of relational, like testing if a value is in a list. That's an important operation. Is 10 in my list? Is 5 in my list? Those are important operations. So we want to learn about these operators, and they're going to be really important for us going forward, is because these will be very standard things we will use as we go along. So we're going to spend some time talking about operators. So it turns out in Python, you can kind of group operators into many different categories. There's going to be standard arithmetic operators. Those are your everyday things like plus, minus, division, multiplication. Assignment operators, which we've already seen, is things like equals, where we're setting a reference equal to something. We've already seen that. That's an assignment. Comparison, which is things like greater than or less than. Those are important for comparing values, comparing variables. Logical operators are going to be something like and or, which will do a logical operation between two Boolean values. That'll be important. And then we have a collection of miscellaneous operators. Those will be things like, is something in a collection, like is 5 in a list? That's an operator. So we're going to talk about all of these, but just pointing out that there's many different categories of operators in Python. Okay, let's first talk about the arithmetic operators. So these are going to be your standard everyday operations between numbers. So if we have numerical values like integers or floats, we can do math between them. That makes sense. Like that should be a capability of Python, and it certainly is. We can add things, we can subtract things, we can multiply things, we can divide things. So here are all those operators. We have plus, minus, the asterisk is the multiplication. So x asterisk y will multiply those together. So if we have two variables, one of them is 50, one of them is 4, we do x asterisk y, that's going to multiply them together to get 200. Pretty straightforward. Division is one that we should be careful of. Of course, like we don't want to divide by 0. So if the this secondary value that we end up dividing by is 0, that'll give us an error. The interpreter will say, hey, you're trying to divide by 0. We can't do that. It'll produce an error. So that's the only thing we have to be on the lookout for with division. Just don't want to divide by 0. So all these are pretty standard. I think they all make sense. Hopefully they do to you. I think they're all pretty standard. The kinds of things you'd see on a basic calculator. They all make sense. They should exist. Now, here's some more exotic ones. I don't know if you guys have ever seen the modulus operator, also known as modulo. This is one that returns the remainder of a division. Okay, so the percentage sign is a mathematical operation between two numbers that returns not the quotient, like not the actual division result, but the remainder. So 50 divided by 4, 4 goes into 50. It goes in there 12 times evenly, but it has 2 left over, right? So the remainder there is 2. So the result of x mod, we would read this as x mod y or modulo y, returns 2. So if you're unfamiliar with the modulo operation, that seems a little bizarre that you take these two numbers. Oops. It seems a little bizarre that you take these two numbers and you like do this operation and you get a remainder result, but it's actually a very powerful operation. The reason being is that sometimes we want to know what the remainder is more than we want to know what the quotient is. For instance, things that are very like cyclic in nature. So maybe we cycle through a collection and we want to know like how many times do we cycle through, and then we have something left over, which is the remainder. So the modulo operation is pretty useful. You can also check like if a number is even or odd using this. Like, so if you modulo by 2 and it returns 0, that means it's even, right? Because that means there's nothing left over when I divide by 2. So modulo is kind of a nice way to check if a number is even or odd. So modulo is a pretty nice operation. We'll use it from time to time, but that is the percent operator. So x percent y will look for that remainder of the division. Now, there's also a double slash operator, which is the integer division operator. This is kind of the reverse of modulo. It takes the largest integer quotient that we can do from a division perspective. So remember I said 50 divided by 4. We can divide 4 into 50 12 times evenly, and we have 2 left over. So the integer division will just return to us an integer always, which will be that quotient. So this is the quotient, and this is the remainder of 50 divided by 4. So the integer division returns to you that whole number, like the largest number of times that number goes into the other. So 12 times evenly. Obviously, there's a remainder there, but yeah. So integer division, that one's useful if we want to know like how many times can I fit a value into another value a whole number of times, and that happens from time to time. We may need to know that. Okay, last operation here is exponent. So the exponent is the asterisk asterisk operator. So that raises a number to a power. So for instance, like x star star y or asterisk asterisk y would mean that we are doing an operation like 5 to the 4th power, which is 625. Okay. So asterisk pretty useful. Like probably the most common asterisk would be squaring something, which would be x star star 2 would be x squared. So, I mean, that's a pretty common operation there, is to raise something to the 2nd power, or maybe the 3rd. Raising something to the 4th, probably less common, but the asterisk asterisk operator is how we do exponents in Python. Okay. So these are all basic arithmetic operations we can do between variables in Python. All right. Any questions on those? Do those kind of make sense to us from a syntax perspective? Pretty straightforward, I think. Hopefully nothing too surprising there. You used to use module all the time for date calculation. Yeah. Yeah, like when you find out how many like days, how many weeks, or where you are in the week, you cycle through like modulo 7 or something. That makes sense. Okay, very good. Okay, I want to talk about assignment operators now. Now, we've already seen this, which is the basic equal sign. That is a data assignment operator, right? So that means that we are setting a value equal to a reference. So we are storing data inside of this reference variable A. We use the basic equal sign as our assignment operator. So that equal sign is called the assignment operator. Now, what's really awesome is we can combine this basic assignment operator with our arithmetic ones to update values um, and modify them as kind of a shortcut to say, so for example, like a plus equals 5 really represents the fact that I want to reassign a to the result of a plus 5. So this means take whatever it is, add 5 to it, and reassign it to the value of A. So this is the same thing as if we just shortcut it, and Python will recognize if we do plus equals 5. It's the same thing. So, and actually we can do that with any of these arithmetic operators. So if we want to take a variable, multiply it by 2, and reassign it to that variable, we can use star equals. So like A asterisk equals 2 is the same thing as if we were to reassign A to the value of A times 2. Does that make sense on the reassignment portion of that? So plus equals, divide equal, modulo equals, star star equals would exponent something and reset it back to the variable. Minus equals will subtract and reassign that back to the variable. So, x minus equal 3 will subtract 3 from x and basically update it, right? Reassign it back to x. So that's pretty useful. Like whenever we need to do an operation and add, like, um, you know, a a very typical reassignment is to do like a plus equals 1. That's a very typical reassignment because what this is the same as is A equals A plus 1. So that's like a single increment of A. We're just updating it by 1. So plus equals 1, we may see that from time to time. A loop coming on, yeah, yeah. These are used in like while loops. Yeah, like you do plus equals and you increment it until you reach a certain condition. Yeah. Now, if you're coming from other languages, if you have programming experience, you're coming from other languages, Python does not have an increment operator like plus plus. I wish it did, but it doesn't. So like I know in Java and I think C, they have you can do like a plus plus, or actually reverse, you can do plus plus a, but that does not exist in Python, unfortunately. You have to do the plus equals reassignment. So they don't have an increment operator. You'd have to do just plus equals 1 to do the same effect as plus plus. So I know some people ask about that, but yeah, it doesn't exist, unfortunately. All right, any questions about assignment? It's just really the equal sign, and we can tack on the arithmetic to do some type of basic math and reassign to the variable. Hopefully, the fact that we're using a single equals makes sense. Where people get confused all the time is the difference between a single equal sign and two equal signs, which we're going to see. Two equal signs means something completely different than a single equal sign. Single equal sign is an assignment. We are taking data and storing it in a reference variable, right? But multiple equal signs, we're going to learn about what that means. That's actually a comparison. It's something different. All right, we'll continue. Thank you, guys. All right, so we're talking about comparison. So we're going to talk about a few operators that allow us to compare two values. Now, this is going to be useful as we go forward because sometimes we want to know when is a value bigger than something or less than something or equal to something, not equal to something. Those comparisons are going to be useful. And we have a collection of operators to do that for us. So again, one that I think a lot of people get confused on is the equals comparison operator, which is the double equals symbol. So A lot of people get confused on that. What is the difference between a single equal sign and a double? This double equal sign is checking if two values are equal. So for instance, we have these two numbers, x and y. They're both integers that are 20. We check if x equals to y, and that returns true because these two values are the same. They both equal 20. So when x equals y, that is a true statement. So that's something to realize is that these comparisons are things that return Booleans true or false because a number is going to be bigger than another, yes, true or false. They are a comparison that gives us a kind of a yes or no answer. Um, so the equals checks if two values are the same. And then the not equals operator, which is an exclamation point with an equals, checks to see if two values are different. So they are not equal. So for instance, if we had 45 and 24, we do x not equals to y, that would return true. Now, if we had these two values as before, and we checked here, x not equals to y, this would be false because they are equal, right? So not equals to checks if values are different. So that's a simple comparison. Are they not equal? So in this case, that would return true. So these are pretty useful if we want to compare directly, is a value equal to another? We use the equals. If they're different, we use the not equals. And we're going to have different scenarios where we will use those. I also want to call out the basic, greater than and less than. So this first one is the less than operator. It is going to be obviously returning true when a number is less than another number. So when we have things like 20 and 30, this x less than y would return true because 20 is definitely smaller than 30. So this returns true. And then greater than checks if a number is bigger than another. So that comparison, x bigger than y in this case, would return true as a comparison. So again, these are all operators that check comparison between two numbers. That will be really useful as we go forward and start to work with data and numbers, and we do comparisons. We will do those all the time later on. Now, there's also scenarios where when we want to know, is it less than or equal to? So that operator just tacks on an equal sign. So less than equals is the less than or equal to operator. So for instance, 10 less than or equal to 30, that is true because 10 is certainly smaller than 30. But it would have been true even if x was 30. That would also be true because 30 equals to 30 would equal to 30. That would be a true statement. Greater than or equal to, same scenario. We have a greater than, and then we have an equal sign right after it. This returns true if something is bigger than or equal to another number. So here's an interesting one. We do 30 bigger than or equal to 30. That returns true because 30 equals to 30. That makes sense. So less than or equal to, bigger than or equal to, we can do with these simple operators. Is greater than similar to the usage of brackets? No. So greater than or greater than is what's called a bit shift operator. It's a little bit different. I'm going to save any explanation. Just look that one up is what I'll say. It does like a bit manipulation, which is a bit of a hassle to deal with, but we won't ever use greater than, or we won't ever use greater than. It does some sort of shifting operation, like a bit mathematics, which we don't need to do. Okay, so those are comparisons. Let's look at our logical operators. So now these ones are going to be really, really interesting and useful when we get into controlling the flow of our program. So logical operators are used for combining conditional statements. So conditional statements are things that return These are statements that return true or false, so they return a Boolean, and it's like we are combining them together in certain ways. Okay, so the and operator, let's look at that one first, which in Python is the literal word and. So that's very nice. It's literally the keyword and. And what this does is it takes the result of some Boolean comparison and some other Boolean comparison and returns true if both of them are true. So and will only return true as a combination if both individual statements are true. They both have to be true. The moment one of them is false, and will return false. So this is useful for doing a combination of things where we want every individual thing to be true. So A equals 1, this is a true statement because A equals 1, and then B equals 2 is a true statement. So both of these would be true. So therefore, when we combine them with the and, this overall combination is true. So keep that in mind. These operators are ones that combine individual logical statements or conditional statements, right? Okay. Now, the one that is less restrictive than and is the or statement, which is used when you only want at least one of the statements to be true. So if we want to combine these things and only require at least a minimum of one to be true, we use the or statement. So for instance, A equals 1 is true because A equals 1, so that's true. And then B equals 2 is false. So this one is false, but that doesn't matter from the perspective of or because we have a minimum of one of these statements being true. So or, when we use the logical combination of or, we just need either or to be true. So A equals 1 is true, so this overall returns true. So or is something that will combine conditional statements and return true if at least one of them is true. If all of them are false, or it would return false because none of them would be true. Okay, so we have and, we have or, and then we have not. So not is an interesting one. Not essentially reverses a Boolean. So if we have a statement that is inherently true and we put a not in front of it, it will invert that to be false. If we have something that is false and we put a not in front of it, it will return true. One of the interesting examples in Python, and this trips up people all the time, is the fact that Python treats 0 very specially. So the integer 0 is, oops, the integer 0 is inherently treated by Python as false. So Python treats 0 as false and then every other integer as true, basically Python is indicating that it is something that is not 0. Anything, so like B equals 1 would be treated as true because it's, as long as it's something that's not 0, then Python treats that integer as a true Boolean, essentially. So why that's interesting is if you put a not in front of this would actually return true because not false, what is the opposite of false? It is true, right? So not false, it would return true. So we will see not from time to time. Not shows up when we want to negate something. So when we, maybe we have an iteration, an iterative loop, and we say while not finished, and then we will execute a bunch of statements while we continue to not be finished, and then the moment that it finishes, then the loop would be over. So not is powerful to kind of invert trues to falses and falses to true. So maybe we want to check if something is not empty, meaning that if it's empty, if it's not empty, that would be false. Not empty, maybe it would return true. So not is something we will see from time to time as a negation operator, logical negation. Okay. Any questions on any questions on these operators? These we're going to use these in the control of the flow of our program. One more example for not. Yeah, so a pretty typical case for not would be something like this, where uh, maybe we have some code. Oops, I always forget to swap over to this. Maybe we have some code that checks. So if we have a list, and it's empty, okay, and it has nothing in it. Let's say it has nothing in it. We could have some code that says like um if not list, um then we then do something. So then if not list, meaning that it's not empty, then grab the first value. Let's say that, grab the first value. So we'd have some code like this. So this not is used to, like, we can negate the fact that this is going to be empty, and then this would be true, and then we can continue to access something because that would mean it's not empty. So not empty is a pretty standard use case for not, like to check that something is not empty. Can we also use not for checking value in the list? Yeah, that's what we're doing here, to say like, is it not empty? Okay. All right. Let's go to some miscellaneous operators. So we have now, some of these are going to be incredibly useful. The one on this page, not that useful. That is mainly because it's very rare that we would check these. So is what we call the identity operator, and this is something that checks to see if two references are the same. Okay, two references are the same, meaning that they're referencing the same piece of data. So now, this is a very interesting case where we have A equals to a list, B equals to the list. However, when we ask the question A is B, this would actually return false. Now, that seems very counterintuitive, but the reason that's the case is because we are creating two different references. We're saying A equals to this list, B equals to this list, which is a whole new piece of data. It's a whole new piece of data. So therefore, we can't claim that they're the same reference, even though they're this. Now, what would be true is A equals B because their data is the same. That would be true, but their references are different because they're different variables, right? A and B are different variables. Different memory location, exactly. Different references. So A as B is the same as checking if ID A equals ID B. Does that make sense? That's basically checking that logical comparison if their addresses are the same. It's the same check. So is basically a shorthand for doing this. And so those would be false because they're going to be two different references, A and B. However, we can use our not. So A is not B. That's actually true because it's the inverse of is, right? So that actually would invert the false, and this would be true. A is not B. That is true. Behind the scenes, yeah, like the memory, yeah, the location in the computer memory is different. Yes, because they are different variables, different references. Yeah, the data is equal. The data is equal, but the references are different, which is what this checks. You know, we have two different names, A and B, those are different. Now take a look at this last example. This is saying A is a list, B equals to A. Now remember what that does. That is the assignment of, we're saying B is the same reference as A. That's what this does here, the same reference. So does it make sense to us that when we ask now A is B, this should be true? And it is. Like this is true because they are literally the same reference. We're setting B equals to A. So they are referring to the same data now. In terms of a variable reference. So now their IDs are the same, essentially. Their memory locations are the same. If you want to compare only data, then what operators have we looked at that are comparison? We should think about that. I mean, we just saw, if we go back a couple slides, we have a bunch of operators to compare data. That's these guys, right? Like equals equals, greater than, less than. So what we could do is say, does the data equal the other data, which would be something like this equals equals operator, when two values are equal, not the references. Does that make sense? This equals equals is checking if two values are the same, which is the data, not the reference. Okay. Now I want to show you a really powerful miscellaneous operator, which is going to be the in, or what's called the membership operator. So this is an operator that checks if a value is a member of a collection. So this could be like where we have a list, a tuple, a dictionary, just a collection of data. And we want to know, is a value a member of that collection, which is really useful for testing, do we have membership of something inside of something else? So for instance, let's say we have a list and we have a list A equals, and then we have 20, 45, and 10 inside that list. So if we ask the question 10 in A, this actually would return true because 10 is a member of A. 10 is a member of that list. So that is true. Now that's useful to know. So the in operator is a really powerful operator. Same thing with not. So we can use not in. So 10 not in A would be false because there it is. We know it's a member of A, so that would be false. Of course it's in A. We can see it right there. It's a member of that list. But if we check the different value that's completely not inside of A, 30 not in A, that would return true because 30 is not a member of that list. And by the way, this in operator works for all kinds of collections. So it would work for a tuple, it would work for a set, it would work for a dictionary. Um, it would work for all kinds of collections. Yeah, Roberto, it's the fact that they're different variables. So sometimes it makes sense to have different variables that maybe they have the same value, but they're different variables altogether, different references. And the reason that is because maybe we have a copy of that data, and then maybe we manipulate this one. Maybe this is a copy of it, and we manipulate this guy, and we leave this guy the same to check the differences later. Yes, references are tied to the variable, like A is a reference, B is a reference, even though their data that they're pointing to is the same value. Maybe we just have a copy of it and we manipulate one of those copies. Yeah, that's why. What is the reason to check for what? If they're equal, like as references, A is B. Honestly, there's not many good reasons. Maybe if you want to know if something is a copy of something else, like you want to know that. Like let's say you're checking later down the code and you have an A and a B and you want to know if one is a copy of the other, you can check and see if they're the same reference. That's the only reason I could think of why you would do that. It's rarely used, but it is an operator that I wanted to show you in case you do stumble across it. somewhere and you're reading about Python or something and you see the is. Like that's the only reason I can really think of is to check if something is a copy of another, meaning it's the same, like maybe it's the same reference. B equals to A, then we could check A is B, and we know that then they're the same reference. Yes, the is operator is comparing references, not the values. That's true. All right. How do we feel about this in operator, like the membership operator? Does that make sense? If you're checking if a value is a member of a collection, that's going to be highly useful later on. Highly useful. This one we will use quite a bit. The is we will probably rarely ever use, but this one we will definitely use. Okay. So I wanted to quiz you guys. What is the main difference between the equals equals and the is operator? What is the main difference? We've just been discussing this, so hopefully this one is easy. Been discussing it quite a bit. Yeah, Roberto, now you know the answer. Perfect. Yeah, it is B. All you guys answering B, perfect. It is B. Good job. You guys are right on top of that. Good job. So just wanted to point that out. Like equals equals compares the values. We're doing a comparison. Is checks if the references are the same, which is the variable reference, like the memory location. Yes, it is. Identity is the same as, yep, that's what we mean. The references are the same. All right, so wanted to do a short demo on the operators, on comparison, etc. Wanted to just show off that demo so you can see and practice with it a little bit. So let's hop over to demo 6 inside of the lesson 1. I'm going to hop over to that, which will be our last thing we will do in lesson 1, and we'll move on to lesson 2. Let me pull up demo 6 here. Give me a moment. All right. Let me share my screen. All right, so demo 6, hopefully you guys have access to this. This is the last one inside of lesson 1. Now, again, this one says try to use VS Code. You can if you want. Again, Colab works fine. You can use whatever you've been using, Jupyter, Colab, VS Code, whatever works for you. No big deal on which one you use. So no worries on any of this. Oh yeah, so F is so yeah, that's a good question. What is F? So F tells Python to format. F is short for format. It's basically format the string which we're going to print by having some placeholders, and we have variables called A and B, and this fills in the blank of these placeholders with whatever the values of A and B are. So F just allows us to format and fill in the blanks. Does that make sense? Like wherever these braces are, we have a variable name inside of it, A and B, and we are going to fill in the blanks of those A and B by by just replacing them whenever we do the print function. So there, think of it as F is short for format. And we have a couple placeholders, and those will be filled in by our variables A and B. Okay, so this demo does a bunch of operators. So it's going to do a bunch of comparisons where we input one number and we turn that into an integer, input another number, turn that into an integer, and then do a bunch of comparisons. So I'm going to jump over the notebook. I'll do that for us to show that off. But that's all we're doing in really in the beginning of this demo. So let me jump over to the notebook and show off that so we can see it. But it should be straightforward to follow because we've done a lot of that already. Okay, so hopping over to the notebook again, feel free to use whatever you want to use. You can use Colab, you can use Jupyter, you can use VS Code, whatever you use. Let's store a variable as A and let's make it an integer. And let's do enter your first number. So we will do that. Let's run that. So let's enter our first number. Let's put in 10 or whatever you want really, but I'm going to put in 10. So that gets stored as A. Now let's do a second number and let's do int input, enter your second number and let's input that. So now I'm going to put in a second number. Let's do 20. So now we have A and B. Now let's do some comparisons. So let's do print. Then we can do, let's do the F formatting like they had in there. Now, what this is going to be is we are going to check A greater than, or let's do greater than B is, and then let's do comma A greater than B. Let's compare those two numbers. So now this is doing the comparison. A greater than B is going to compare those two integers. What should this return? What should A greater than B return? Should it be true or should it be false? Should be false, right? So we should display false here. And that's what it is. 10 greater than 20 is false. Okay, so that is false. Let's do another one. Let's do, let's try equals equals. So let's say A equals to B is, now what do we think this one's going to be? A equals to B. What should this one be? Yes, very good. This one should also be false. Let's run that. And that one will be false. Very good. Okay. So I think we get that. Let me give you guys let me show you something interesting. Let me go a little off script from that demo document and let's introduce a third number called C. Let's do a third integer. So enter your third number. Let's do a third number. Let's enter another value of 10. Okay, so we have another number of 10. Now, what I want to do is let's just do multiple comparisons and do a logical operator between them. So let's do A not equal to B and A less than C. Or sorry, B less than C. What do we think this is going to return? This might be a little challenging. What do you think this is going to return? We should use F. We can. I'm just not printing. I'm just gonna run the cell. I'm kind of doing a shortcut and just print. I'm not gonna print. I'm just gonna run the cell and it should display what it is. Do we think it's gonna be false? Yeah, you guys are right on top of it. Should be false. Now let's break that down. Why is that false? So A not equal to B is checking if A is not equal to B, which is true. A has a value of 10. So A has a value of 10. So 10 is not equal to 20. That makes sense. But 20 is not less than 10. So this part is false. So let's make a comment. So the reason this is false is because B is not less than C. So and returns false. Yes, very good. Now, what if I take this code and do this? What's this? Perfect. Yeah, you guys are right on top of it. This should be true. And it is. Now, that's because the moment we have at least one true, which is going to be this, that makes sense, right? That is going to be true. Okay, one more, and then we can wrap up this demo. So I want to create a list. I'm going to call it X, and I'm going to create a list of three numbers, 10, 20, 30. Okay. Now, what do you think this result is? What should this be? It should be true. Very good. Should be true. Now, what should this be? This is also true. Very good. This should be true because this is not going to be inside of the list. So that makes sense. That is not true. Now, what I want you to notice is nothing will change if I change this to a tuple. Nothing will change. We can still check. So we can still check if 10 is a member of this tuple, and we can still check if 40 is not a member of this tuple. So nothing really changes, right? It's still in membership operator in checks, is it a member of any collection? Okay. Very good. Any questions about these examples? Any questions? Do we feel comfortable with some of these operators? You guys were right on top of it. It was very impressive. You guys got those right away. You changed print A equals B and A is B, and I entered 4 both times, and I got the same result, true. So you had your A and your B. So you had A equals to 4 and B equals to 4, and you checked this. Yes. Yeah. So that is a little confusing, and I can understand why. So the reason this ends up being true is because this is a scalar data. So for scalar data, it's going to optimize in the memory to point, because 4, the integer 4, occupies the same memory address always. But when we create an array, when we create a list, that is a new object. So yeah, that one's a little confusing, but it's only because this is scalar data that Python kind of knows, okay, 4 is the same like integer in memory always, regardless of if we're referencing it from two different variables. That's the reason. Um, yeah, I forgot to mention that example, but it's purely so the reason this is true is because this is true because of scalar data optimization. Essentially, it's not going to waste creating a new object when it's just a single integer 4. It basically occupies the same memory address uh, as a reference. But when we build a list, like that is a different object. Okay, very good. All right, so that will wrap up lesson 1. What I'm going to do is go into lesson 2. I'm going to pull up the lesson 2 notes, the slides for lesson 2. So if you have those, let's pull those up. I do encourage you. Now, there is a guided practice at the end of lesson 1, and that is for yourself. I would encourage you as kind of homework between now and the next time we meet, to do the guided practice for lesson 1. Try that out on your own. It is, you guys should have access to it from your LMS and the reference materials. There's a guided practice. Try those out. Okay, try out the guided practice for lesson 1. It's just some additional practice of the things we just covered. Okay, let me open up lesson 2. Give me a moment here. Okay, so let me share my screen. Okay. So now we're going to move on to looking more closely at those things like lists, tuples, dictionaries, and then looking at control flow with conditional statements and loops. So we're going to get into the fun stuff, I would think, that you guys may have been waiting for. Okay, so we've talked about, we just finished talking about lesson 1, where we have, Python as a really important thing to learn and study because it's used all over the place with data science and AI ML. So one of the things is we need to continue learning about it with things like loops, things like if-else statements to control the flow of our programs, and these basic data structures. Let's continue forward. So this lesson, we're going to talk about lists, tuples, dictionary sets. We're going to, talk about the differences, how we can access data within things like lists, how we can modify them, how we can access things from tuples, what are the differences. We'll review all that. One of the big topics is going to be to look at how we can control the flow, meaning control the flow is using like decision logic, like if this is true, then do this, else do this. We'll talk about those kind of statements. We'll talk about iteration. So how we can do loops to repeat statements of code that we want to do. We'll also talk about organizing our code a bit into functions, which is going to be really helpful for our own organization and reuse and maintainability. Okay, so let's jump into it. Let's talk about some of those data structures. So we've already talked about that these aggregate data structures exist, and they allow us to manipulate data inside of Python. Lists, tuples, sets, dictionaries are the main ones we're going to focus on. Let's start with lists. And I think lists are going to be something we're going to use quite a bit of throughout. So they're going to be a really good place to start with. They are super popular in Python. A lot of people use them to work with data. They are kind of the most basic and useful data structure that there is. So what is a list? A list is an ordered, mutable, meaning it can be modified data structure that can hold elements of different data types. So it's a collection of data. And there's no requirement that all the members of the list be the same type. In fact, you can have different types. You can have integers, you can have floats, you can have strings, you can have even more abstract objects be members of a list. So any kind of data can live within a list, but the big thing is that it is modifiable. It's dynamic. You can change, you can add things to it, you can remove, you can change things. And it has an inherent ordering, which is nice. So you can be reassured that there is some inherent position of items, and it will maintain that order. So we can access things based on the order. Like we can access the first, we can access the last, we can access anything in between. So that's nice. So what are some key characteristics? So lists support multiple data types. We talked about that. There's no requirement that they're all the same. They can have multiple. They allow for indexing, which we're going to talk about. This means that we can access things based on their index, which is their position within the list. So we can always access the first thing, the last thing, anything in between based on its position. That's another word for index. Because lists have natural ordering to them, which is really, really powerful to ensure that there's there's a first position, a second position, third, etc. So lists are really nice for that. They are modifiable, which is really nice. So we can add things into the list. It's very dynamic. So once we create a list, we can, throughout our program, we can add data to it. We can remove it. We can change. Lists also allow duplicates, which may be desirable. Like maybe we add something into our list that already exists. That's okay. Lists allow duplicates. This is going to be different than sets. Sets do not allow duplicates. Sets are just a bucket of unique things. So if we added a duplicate into a set, it would reject it. We wouldn't have any errors, but it just wouldn't show up as a copy. We would just have a set is only going to maintain one copy of an item. It only allows unique items. Lists allow, you can have as many copies of data as you want inside of a list. So it does allow duplicates. Now, we already saw in terms of syntax, lists are defined by brackets. So when you see those brackets, it defines a list and its items are separated by commas. So we can have a list that looks like this. Yeah, I was going to explain slice. We have a couple slides about slicing coming up, but slicing means that we can grab a section of elements at a time from a list. So for instance, we can actually, let me use this example down here. A slice would mean we can grab like these first three slice of the list, or we can grab the last 5 elements or whatever. Like this is a slice. It's just a subset of the list that we can grab, we can access. So slicing just means taking a subset, taking a smaller section of the list, and we can grab all those elements at a time. And what that's called is within a slice. Yeah, like a slice of pizza. We're taking the whole thing and we're taking a small section of it. So that's going to be possible because the list has a natural order to it. Does the data have to be sequential? No, it doesn't have to be. In fact, it can be completely different types. Does that make sense? Like, so look at this example down here. Like we have 10, 2, 5, hello. That's a valid list. You can have different types of data in there, which isn't sequential at all. In a slice, no, it doesn't have to be. So you can have a slice that picks every third element, every other element. Yeah, it doesn't have to be sequential. No, it can be customizable. What's also nice is you can slice from the beginning or you can slice from the end as well. So you can go from the end and slice backwards. Or you can go from the beginning and slice forward. So you can grab like every other element from the beginning. You can grab every other element from the back and work your way forward and stop at a certain point. Slicing is very nice. Yeah. So I'm going to show us how to do that. Can you slice in the middle? Yeah, you can slice anywhere you want. Can you slice a pizza in the middle? Sure. Would you do that? Maybe not. But yeah, you can slice anywhere in the list. You can slice. Does slicing change the original list? No, it's just selection of a subset. No, it just extracts elements. It doesn't like permanently change it in any way. It just gives you a view. Think of it as like giving you a view of that subset. Okay. So you may be wondering, when would I ever use lists? So normally you use lists whenever you want an ordered collection that is dynamic, meaning you may want to add things from it. We may want to modify things from it frequently, but we want something that is dynamic and has an ordering to it. Lists are perfect for that reason. So they can contain data that we can add to, remove from, change. So lists are very versatile. I think most use cases with manipulating a collection of items would fall under a list. A list would be a very good choice. Um, We can slice elements and use them. Yeah, yeah. You can store a slice inside of a variable and use that resulting variable. Yeah, for sure. Order information like, yeah, yeah, that's a good example. Yeah, order like the collection of orders would probably be in a list because it can change. But the prices would be probably static, so that would be more suitable for a tuple. Yeah. A tuple or maybe a dictionary. A dictionary is probably better because you can have like a product ID or a name that maps to a price. Probably a dictionary would be more appropriate for a price list. But but yeah, tuple maybe makes sense too. By the way, look at this list. You guys see how it has different types of data in it, right? It has so like the first element's an integer, the next is a string, the next is a float, then the last is a Boolean. That's totally valid in Python, which is kind of unique to Python. Like a lot of languages don't support that. A mixed typed array they don't really have that notion of that. All right. So what I wanted to get to was the positions. So this is really important to pay attention to because this is going to be something that we will be using throughout the program is how to access data by its position. Okay, so there's another word for that. The position, sometimes you will hear called the index. So the index in the list of where data members live is their order, like their position amongst the list. So what's special about Python is that it has the first position is index 0, which trips people up all the time. The very classic trip up of Python is that the first element of a list is at position 0. The next element is at position 1. The next element is at position 2, on and on and on. The last element is at position n minus 1, where n is the size of the size of list. So however many elements we have in our list. Um, so if you want to access the first element, you would be looking for the element that's at position 0. If you want to access the second element, that's this name Bob, that is at position number 1 or index 1. So that's something that trips up people, is that it actually starts at 0, which is really important to understand, is that the positions start at 0. Why is that? That's a good question. I mean, different different languages treat that differently. It's more historical reasons that it was created that way. But I think it's based on your think of it as like how far into the list you are. So if you're in the beginning, that means you're basically at position 0 because you haven't made any progress like traversing the list. I think that was the intuition. Oh yeah, which is kind of what Tim says there, is like, yeah, if you're at the very beginning of the list, you're at position 0 because you haven't made any forward progress in traversing. So it's like you're at step 0, you're at the beginning. Okay. But okay, so aside from why it was that way, does it make sense that the first, like what I'm saying is the position 0 is the first element, position 1 is the second element, position 2 is the third element, and on and on and on. That's how it works in Python. Okay. Now, what I'm telling you is the positions if you were to view it going left to right. So in other words, in the forward direction, we start from 0 and go up to the n minus 1 in terms of the position. Now, what's really convenient is the positions can also be indexed from back to front, meaning they can also be indexed going this way. And what's really nice is the very last element starts at position -1. The very last element on the right starts at -1 and then goes all the way up to -n. Okay. Now that's really convenient because if we want to access the very last element, I don't need to know how big the list is. I just need to access the position -1. That guarantees to access the very last element. The -1 position is the very last element. And then so this is the very last element. This is the second to last, third to last, fourth to last, on and on and on. And then by the time you get to the front, it is -n, which is like the number of elements in the list. So in this case, -6 is the very beginning. Now, why in the world do we care about negative position? It's for that exact reason. If we can think about the positions from the end of the list going backward, which is very powerful. Like if I want to access things from the very end, I don't need to know exactly how many there are. I just need to know -1 is the end, -2 is the second to last, -3 is the third from last, which is pretty convenient. Okay. So does that make sense on the negative index? The negative index is going from right to left. It's from the back to the front. -1 is the last element. And then you go second to last, third to last, right? And that is -2, -3, -4. So from right to left, yeah, right to left, -6 is actually the first element because it's 6 back from the end, which is the front. There's only 6 elements. Yeah. So are there any questions about this? Is really important to understand. Really important to understand because this is how we are going to slice and access data is based on these positions. Is there a syntax to get the number of elements in a list? Yes, it's the length function, which is len. So length of list, would give you the number of elements, which in this case is 6. So len, the length function, gives you how many elements are in the list. Len, or length. So this guy, this function. When are you counting backwards? You're usually counting backwards when you want to know what's at the end of the list. So when you only care what has been added at the end, and you want to, maybe you want to get the last 5 elements. So you slice backwards from the end. That may be useful. Like maybe you want to know, like imagine a list is holding in your orders, and so you want the last 5 orders. So you can just go from the back and go towards the front. -1, -2, -3, -4, -5 would be the last 5 orders. There's going to be many scenarios where we want to count from the end when we're manipulating data. Later on, when we're working with bigger sets of data in something like a matrix, it's going to be useful to grab like the last 5 rows, last 10 rows. So going from the end makes more sense. So imagine if we have like a larger matrix of data, maybe we want to slice out these last 10 rows, in which case we want to count from the minus, like the last row is -1, and we want to go back towards the front. Can you sort? Yes, you can sort. I'll have an example of that in a second. Yeah, you can sort. There's a built-in sorting function in Python that will allow you to sort data in a list. Yes, there's a built-in function for that. Okay. What I wanted to do is show you guys an example of accessing elements from the list. So assuming we know the position, which is that index, all we have to do is use brackets to access items of a list. So imagine we have this list called fruits, which has some strings in it: apple, banana, cherry, mango, and we want to access the first element. So that is just this code here: fruits bracket 0. So the bracket tells the interpreter, hey, I want to access something within this list. And then all we have to do is give it the position that we want to access. So this is position 0, which is going to be the first element. This would retrieve the first element. Now, it's not removing it, it's just accessing it so we can view what that is. So it's actually going to give us a copy of what that value is under the hood, basically a copy of it. It's not going to delete it, it's not going to remove it. It's going to give us a copy of what is at position 0. In this case, apple. Now, if we put in a position 2 in that bracket, that should be, remember, the indexing is 0, 1, 2, 3. Because there's 4 items, so the last element is n -1, which is 3. So the item that's at position 2 is going to be cherry. So this should return the string cherry. Okay, so we always use this kind of syntax, position, to access the element that is at that position. Okay, pretty simple. And what's really nice, by the way, about this is the same exact thing works for tuples, because tuples also are ordered. So we're going to see that when we get into tuples, but the same exact things works where a tuple has a first item, a second item, a third, which are index 0, 1, 2, 3, and we can access things in the exact same way. So we can access a tuple by its position as well. Same exact thing will happen, position. So we can get the first item of a tuple by doing 0, and we can get the last by doing -1, and on and on. Any questions about the accessing? Can we get position based on value? Yes. So that is a special function called index. So if you do like list dot index, and then you pass in a value like Apple, this would return to you the index of the first occurrence. Not every occurrence, but just the first. So like, because we could have multiple copies of Apple in our list, but the first time we stumble upon Apple, this would return 0 because Apple occurs at index 0. So dot index function would return the index, which is the same word as position. Okay. All right. Any other questions? We can. I think what we'll do is we can take, if unless there's any other questions, we can take a short break and then come back and continue. I want to talk about slicing. No, it would return none. It would return null, basically none. As opening closing braces are square on it if it's a list. No, it's actually the same as a tuple. In terms of accessing, it's the same. Uh, it's in terms of accessing, it's the same. For creating a list, yes, it is square brackets. This creates a list. The brackets always create a list. For accessing elements, this is the same as a tuple. The square brackets for accessing. Actually, in most things in Python, it's the same, where we access data using the square brackets. A dictionary, same thing. We access keys by using the square brackets. So square brackets in Python is basically like an access operator. No, so list.index doesn't only work for the first item. What I'm saying is you can have lists that have multiple. I'm saying it returns to you the first occurrence, the index of the first occurrence, because we could have a copy of Apple later on in the list, right? So there's nothing that stops us from having a duplicate. So we could have another Apple down here. Like, let's say we had another Apple at the end of the list. If I did list.index Apple, it's only going to return to me this first one, even though there's another copy of it in the list. So it only returns to you the first occurrence. But there's nothing stopping me from doing list.index of banana or cherry or whatever. Are there data types of Python that support all Unicode characters? I think there's special strings you can make that do Unicode, but I'm honestly not 100% sure. I would research that. I don't really know. I think you can do that with strings, special strings. Yeah, I don't think there's anything inherently special about it that Python can't handle. It's just you sometimes have to like escape characters uh to distinguish them, but yeah. All right, going back to our example, we had the going back to that fruits list, we can access things from the end. So here's an example of us using the negative index, right? So -1 grabs the element that's at the last, that's the last member of the list. So mango. -3 would be the third from last, which is going to be banana. So negative index, really handy to access from the end of the list going backward. Pretty useful there. There's an example of it. All right. All right, let's talk about slicing. Okay, let's talk about slicing. So slicing allows us to extract a subset of items from a list using a specific range of indices. And so the syntax to do slicing is going to be using our brackets again, but we use a colon to specify where we are starting and stopping our positions. And not only that, but we also use a colon to signal how many we want to step by. So do we want to do every other, in which case we would step by two? Do you want to do every third element, which would step by three? So most slicing is going to follow this sort of syntax where we do list, and then we do like a start index, and then we do colon, and then we do stop index, and then we do colon step. Now, what you will see is that the step defaults to a step size of one, meaning we grab every element in between starting and stop. So step size of one is the default. So we actually typically will not include the step size unless we specifically want to get every other, which would be a step size of two, or every third, or every fourth, or every fifth. So usually we leave off this step size and we just have a starting and a stop as part of our slice. And what that does is it tells the interpreter to access everything between this start and stop. So with one catch, which is a very important catch that trips everyone up, which is that Python is very annoying in that when you do slicing, it allows you to include the starting index. So if we start somewhere, we will guarantee that the slice will include that, but it will not include the stopping index. It will do everything between there up to the stop index, but not actually including what's at the stop position. So for example, this slice that you see on the screen is a slice that would be starting at position two, because remember, let me draw this out. This is position zero, this is position one, position two, position three, position four, five, and six. And so this is a slice that would start at position two, is our start, and meaning we're guaranteed to get 34 because we're starting there. But the stop for this slice would have to be here. This is our stop, because we are going to include everything in between there. We're going to include all of this slice as part of our what we can access. So that would be positions two, three, and four. So this slice would be basically like this list. It would start at two and go to five. And then it technically would be a step size of one, but remember, we don't really need to include that. So this would really be list two to five. That does feel annoying. Yes, it's because you have to know where to start and stop, and so Python chooses to be not inclusive of the stopping index, but it includes the starting index, and that's just a choice. That's a design choice of Python. Okay, so the colon gives us the slice. So if you see uh, if you see a colon inside of a brackets, that signals you're grabbing a collection of items. So this actually returns a smaller list. This returns a list of 34, 20, and 80. So it's a slice, meaning we get multiple items rather than just a single item from the selection. No, 54 would not make the cut. 67 doesn't make the cut either because remember, we don't include the stopping index. Can you do 2 to 4 plus 1? Yes, you can do arithmetic in there, and Python will evaluate the arithmetic first. So it will do 4 plus 1 first and determine that is 5. Yes, you can do that. Okay. So before I move on, does the slicing idea make sense? It is grabbing a collection of items from the larger list and we set it up with this syntax. What do you think? What do you think 0 to 6 would return? What would be your guess? What's included in the slice though? It's not just 67. If you go 0 to 6, how many, like you should be getting more than that. Yeah, you should get everything right. Exactly. You should get all of those numbers up to 54. You would not include 54. So you would get 76, you get 12, you get 34, 20, 80, and 67. Yes, that's true. Yeah, so the step relevance is that we can, so from our slice, we can choose our step size of how many like how much we want to skip positions within that slice. So step of 1, which is the default, means we get every position. We increment by one position to the next, to the next, to the next. A step of 2, uh, a step of 2 would be that I'm going to grab every other element from the start. So a step of 2, like if I slice this and change this to a step size of 2, then that would only grab this and this because that would step over, it would take 2 steps to get to the next element of the slice. Whereas a step size of 1 is going to grab everything because it's going to go one index to the next. So think of the step size as how many positions are we incrementing? Yes, 2 to 7 would include 54. Yes, that's right. 2 to 7 would include 54. Okay. All right, let's see some more examples. So if we have a list like this and we slice it from 1 to 4, the output is going to start at index 1 and go all the way up to index 4, but not include 4. So index 4 is this guy, and it's not going to include that. So it's going to be these 3 elements here would be our slice. Yep, 20, 30, 40. Very good. That's what it would be. So that's pretty useful to be able to slice. Let me show you another example. Oops, don't have another. Let me go back. Let me show you another example with this. So what we can do is we can actually slice backwards as well. So let me ask you guys this. What do you think this slice would be? Actually, let me erase this. Let me do minus 4. What do you think this would return? We can use negative indices in our slices. What do you think that would be? Very good. 30, 40, 50. So it's going to go. So remember, -4 is the fourth from the last. So it's going to be, this is -4, and then this is -1. So we're not going to include -1. So we should be doing this slice here. That should be the slice. 30, 40, 50 would be that. Okay. A couple other examples I wanted to give you is that you can actually, in certain special cases, you can actually leave off the starting and stop. And what that would signal the interpreter is that you want to go all the way to the end or start all the way from the beginning. So if you do something like this, let me show you an example. If you do something like this, and you do not include, you leave the start blank. You leave the start blank and you go all the way up to -1. What that would signal to the interpreter is by default, start at the beginning. So start at 0, essentially. Start at 0. If you leave off a slice as your start, that the interpreter assumes you want to start at the beginning. So what do you think this slice would be, knowing that? Yes, exactly. You guys are right on top of it. 10 to 50. Perfect. So it's going to be everything but the last. Everything but the last would be included in that slice. Perfect. And so the other thing is we can leave off the end, which would signal that we want to go all the way to the end. So what do you guys think this is going to be? What would that be? Yes. So this is actually going to include the end. So I know that's a little counterintuitive, but it's actually this guarantees we include the end. So if it's blank, it's going to go all the way to the end, including the end. I know that's annoying. I don't blame you for thinking it should be 50. But it basically goes to n. Basically goes to n, which would mean that we remember the index is n-1 is the last index. So if it's blank, this means we should end at n, which is the length of the list, meaning that the last element is at n-1, so we should include the n-1. So yeah, that would be 20 to 60. Actually, sorry, 30 to 60, because we index 2 is 30. So that slice would be this one all the way to the end. Good. I have one more example for you that's really going to throw you for a loop, is this one. So what happens if we have this case? This probably won't throw you for a loop, but I'll have one more following that. All, yeah, 10 to 60, everything. Perfect. You guys are right on top of that because we're leaving the starting blank, meaning that we should start at the front. We're leaving the end blank, meaning we should go all the way to the end. So that would be everything, everything in between. So at that point, we're not really slicing anything. I mean, we're not really slicing much. We're just taking the whole list. Now, one example I want to give you is what if we sliced and we had a step size of -1? Any ideas what that would do? What does this do? What is a step size of -1? So minus negative index goes from the back, right? So if we're step sizing -1, what should we be doing effectively? So this is signaling we basically want to have the whole list but step by -1. Yeah, so this would be the reverse. So this would be the reverse list. So I know that seems wacky, but that actually is a way to validly reverse a list in Python is to index to step size by -1. Because what that means is you're slicing the entire array, but you're stepping by -1. We know -1, we know -1 goes backwards, right? Effectively, because it starts from the end. So step size by -1 would be go back this way, each element going back this way. So that would effectively reverse the list. Yeah. There is a reverse function. A list has a dot reverse function. So that is in English, but this is an alternative to reversing -1. Step size of -1. No, Roberto, they're not quite the same because remember when you do two colon and then you leave out the blank, that means you're going all the way to the end, including the blank, including the end. So -4 to -1 would be the same as two to six or 2 to 7. 2 to 6. Sorry, 2 to 6. 60 to 10. Yep. It would be so this reverses it, meaning this would return to you 60, then 50, then 40. It's the reverse of the list when you step size by -1. I am sure. How about slice from position one to second to last and reverse it? What do you think that would be? You're starting at one, going to second to last, and then revert. Like we already know what's reversing is step size -1. That will always reverse. What is colon colon? So colon colon is the fact that we're leaving colon colon is not anything special. It's the fact that we're leaving the starting. It's just the syntax of slicing, right? Colon colon is because we're leaving the starting and stopping blank, which we can do. We're allowed to do in slicing. So that would signal that we're doing everything, but we're going step size -1. Yeah. Okay. Any other questions? How do we feel about slicing? Do you feel okay with it? We're gonna practice it more as we go along, because we're gonna use slicing quite a bit when we work with data. But does the concept of slicing make sense? Yeah, you need more practice. We'll do more of it. We're gonna do slicing throughout the program. Yes, we'll do multidimensional in our next course. Not right now, but in our data science course, we'll do multidimensional. That help? Yeah, step can be a very yeah, sure, sure. So there's nothing that's stopping you from, there's nothing that's stopping you from doing like let's say X is 2 and then we do numbers and then we have 2 to 6 and then X. Yeah, that's fine. There's nothing that would stop us from doing that. Do you mean that? I think that's fine. There would be nothing wrong with that. But you're right that it should be an integer. If it's like a float, Python will complain. It needs to be an integer step size, and it needs to be in order to get any meaningful data, we wouldn't want that step size to be too big, or like if we pick it to be like 20 and there's only 5 elements, that's not going to make any sense. The step size needs to be reasonable. All right, so what I want to do is show you some functions that lists have. So probably one of the most useful functions a list has is the ability to append items to the list. Now this will add items to the list, and particularly it will add it at the end. So this is something we will use quite a bit, is the list.append function. So this will modify the list and add a new element at the end. So append always appends to the end. And so this will allow us to take this string cherry, and now when we append it, this list has now permanently been changed to have cherry at the very end. So there it is. It is now at the back of the list, and it is now at the kind of end position when we do dot append. So here you see the list being really dynamic, allowing us to add elements to it through this append function. So append, really, really useful, allows us to add. We pass in an element inside of the append function here that we want to add to the list, and it will go to the back of the list. Lists also have a pop function, which you pass in a position and it will remove that item that's at that position. And not only will it permanently remove the item that's at that position, but it will return it back to you. So pop is really useful if you want to remove things from the list. If you don't provide a position, so if you don't provide any index that you want to remove from, and you just do, if you just do pop without any thing in there, that will always remove the last element by default. So if we just did this, it would remove the 40. Can we append in a specific position? Yes, you would use the insert function and then give it the index you want to insert into. So dot insert would be, every list has a dot insert function and then you put in a position you want to add it to. Is it common use for append and remove during? Yes. So append is really common to add new things to the list, which maybe we're doing like data aggregation. We want to add things to a list and then take the average of the list. That's very common. Remove, yes, maybe we're working our way through a collection of things, and when we process it, we want to remove it. So we can do pop to remove it from the list. Yes. Yes. So when we pop, it permanently affects the list. So everything gets shifted. Yes, all their positions get shifted according to what we removed. So like in this example, 30 is index 2, but when we pop, it now becomes the last element. So it would now be eligible to be index -1, right? Because when we remove 40, 30 is now the end of the list, for example. So yeah, everything shifts. And this example here pops from index 2. So we would go to index 2, which is 30, and remove that. And so 40 now shifts up to be at index 2, whereas previously it was at index 3. Insert as well. Yep. When you insert, everything shifts. Yep. Okay, here's a really useful function as well. So we have the dot extend function, which would allow us to add in multiple elements. So this is the same as if we appended every individual item in this collection to the list. So dot extend takes a list and adds its elements to the other list. So notice that we have a list of colors here, red and blue, and we're extending it with a list of green and yellow, which will result in the colors list now having all of those elements. So extend is really helpful if we want to add in multiple pieces of data to an existing list. A lot of questions. Can we get the index and values with a print command? Yeah. Yeah, I mean, you can use a, I'm not sure what example you have in mind, but yes. Yes, append is one item, extend is taking an entire list and adding all of those elements to the existing list. Yes, append is for only one value at a time. Yes. Extend is when you're adding multiple values. Append is one value at a time. Yes. Okay, so let me ask you guys, what do you think of this? Which of the following method adds a single element at the end of the list? So adding a single element at the end of the list. Very good. It should be A. Yeah, append. Append adds, and append always adds to the end. Very good. Okay, so now we're going to have a demo. And by the way, this is a demo that is an existing notebook. So what you would want to do is, especially if you're working in Colab, is take the notebook. Now this is within lesson 2, so we're going to do demo 1 in lesson 2. You would want to take that notebook if you're working in Colab and upload it. I'll show you how to do that. But we're gonna do the demo that's inside of the first demo inside of lesson 2. So let me share my screen. Okay, so if you're inside of Colab, what you're going to want to do is go to File and then Upload Notebook. So you're going to want to go to Upload Notebook and then pick hopefully you've downloaded the demos, in which case you have the notebook from lesson 2. There's a bunch of notebook files, the IPYNBs. You want to upload those demo notebooks. Okay, if you're working in Colab, if you're working in Jupyter, or you're working in VS Code, you can just open that file within VS Code or Jupyter, and you should be good to go from there. So I've already done that. This is demo 1 inside of lesson 2. Do you guys have access to that notebook? Demo 1 in lesson 2. There should be lesson 2 has a bunch of notebooks that we're going to work through. Okay, very good. So if we run this piece of code that's in this first set, or sorry, first cell, it's going to create this list which has different mix types. So this list has integers, it has strings, it has floats, but we can create this list. We just hit run. We now have a list. And what I want to show you is if we were to check the type of this my list, of course, this should be a list, which it is. Okay. Oh, thank you for uploading that. Perfect. Okay. So let's go ahead and access a few elements. So we can access the first element here. We can access the element, the fourth, which would be at position 3, and then the seventh, which would be at position 6. We can access all of those. And we put those into a new list here by putting them inside of the brackets. So that means that we're accessing this first one. That's the first element of this list that we're creating. It's 25, which is here. By the way, what do you guys think happens if we try to use an index that is too big for this list? What do you think would happen? Like if we tried to use code that would be like my list, and then we put in the index like 20, what do you think would happen? Because there's definitely not 20 items in this list. Yeah, it'll be an error. So let's try running that. This will give me an error that says it's out of range. Yeah, an exception, right? It would be an exception, which would say we have an index error. We're trying to use an index that's too big for our list, essentially. So just pointing that out. Let me make a comment there. This index is out of range for our list. So we should get an error. See how I'm making a comment? Making a comment there to remind myself of why I got this error. So remember, comments are useful. All right. So we access things and we can put those inside of a list. Now let's do negative index. So we know -1 should give us the item that's at the very end of the list, which would be this 2.718. So that should be there. And then -4 would be fourth from the back. -7 would be seventh from the back. So we can get those values, not too bad. Then we have a slicing example. So 2 to 7, we know as a slice, this is a slice that starts at index 2 and goes to index 7, but doesn't include index 7. Right? So that should be the slice. So if we run this code, this would extract everything starting at position 2, which should be the third item of the list, all the way up to position 7. And one other thing I wanted to show you is we can extract how many elements are in the list. So I wanted to show you guys that. This code tells us the length of the list, which would be if we did length of my list. Yeah, len. So we pass that in the length function, we pass in my list, which should give us 10. So there's 10 items in this list. So just wanted to call out that there is this length function that we can do with the list. Can you show printing index numbers for the list? Like, do you mean every number in its index? Do you mean that? Every number in its index? Yeah, so the code that does that is the enumerate function. and we would use a loop. So it would be something like for index value in enumerate my list, and then we could do print index and value. Like that. We haven't learned this. We haven't learned any of this yet, but that's what it's doing. Yeah. Okay. Cool. Let's see. So finally, what I wanted to show is that we can append. So if we take our list, this is what it currently is, and then we append a new element, we can print out the list and you can see how it ends up at the end. So we take that original list and we just add a new element at the end. And then this, by the way, we didn't explain this, but remove will find that value, find the value 100 and remove it from the list. It will find the first occurrence. Yeah, so remove will find the first occurrence of this value. Pop is index based. Remove is value based. So remove will look for the 100 and take that out of the list, but pop will be index based. So if we do so pop is index based. So we could do my list dot pop, and we could pass in 0, which should remove. This will remove the first element, and then we can print my list. So that removed the 25. Does remove all? No, I think it's just the first occurrence. This is the first occurrence. You'd have to do it multiple times if you have duplicates. I think. I have to double check that, but I think it's just the first occurrence. Okay. All right. So I know we're a minute over. Thank you guys so much. What a great first couple of sessions. I think we're picking up this really well. So very good job. A lot of great questions, a lot of good back and forth. So appreciate that. Hope you guys are learning and picking up this Python as we go along. We have a lot more to cover. So, next time we meet, we will continue talking about the other data structures. So we have to talk about sets, tuples, dictionaries, and then we have to get into loops and if-else statements, and then we'll eventually work our way to functions. So a lot more to cover, but we'll get there. But hopefully you guys are learning a lot. Any homework to do? Not formally, but I would request that you guys work on the guided practice for lesson 1. Work on the guided practice for lesson 1, if you can. Okay, so go into your reference materials, find the guided practices, work on the lesson 1 guided practice between now and our next session. Thank you guys. Thank you so much. Thank you I know these 4-hour sessions are a lot. Appreciate your patience. Thank you so much.
And with that, we have reached the end of our course. If you have any doubts or questions, ask them in the comment section below. And a team of experts will be happy to help you as soon as possible. Thank you for watching and keep learning with Simplilearn.